brief introduction and come back here. Hope you received all the mails from our team guys about this one. Today it's going to be a slightly technical workshop guys. So it is going to be a bit technical and we'll try to simplify it and understand. Before that, let me go ahead. One more time, just for the sake of discipline. How many of you have not attended the last one, guys? Last week's session? Could you just let me know? I say only Nitisha. Bunch of me is coming in here. Couldn't attend, I say. So let me just show you something. Science workshop. Let me share my screen. So Nitish Sheikh, Bibhuti, all those guys who did not attend the last week's guys, just go ahead and have a look at this introductory session where I tried explaining in a bit more simple way. And let me go here. Let's go to videos. That is C#, I think, introduction, map reduce. And let's say data science workshop. How do I go there? What's that? Give me one moment, guys. Sorry about that. Thank you, Pushkar. Let me come here, click on this. Let's go to playlist here. Oh, here we go. And let's see, where is data science, guys? Sorry, I thought I had it ready, but let's try this one, guys. Is it this one? I think it is slightly, no. I think this is slightly older one, guys. Huh? Balaji or anybody from the Naresh IT side? Are you there, guys? Can you just send me the link for the last Syam? Can you send me the link for the last week's data science, guys? So that I can share it, I can pass it along. That would be a little bit helpful in getting a, oh, there you go. Thank you. Who was that? Sham or whoever it is. Thank you, buddy. I appreciate that. So guys, let me click on this. Let me come here. Let's do resume. I want you guys to, those who missed the last session, to just go over this one once. It will give you a slightly friendly idea about what we talk. And it will help you understand a few more slightly advanced concepts and things like that, guys. Okay. So that was on 5th July. Please try to, follow that one, guys. It's about 2.5 hours. And we did spend some good amount of time trying to explain some of the basic concepts and things like that, which will set the basis for today. Guys, today is going to be slightly more technical. I will take you a little bit into the, into the technical details, and it might be a little bit complex also, guys. I'm not trying to scare you, but the objective is we want to give you an idea how the real world looks like and things like that. So that's why I'm going to take you to one level deeper and try to simplify it, guys. Okay, so please do that, guys, those who could not attend last week. And with that, let me come back here. Here's a brief introduction, guys, one more time, just for the sake of discipline. My name is Navin Paturu, and I have over 23 plus years experience in IT and analytics, and about 10 plus years I lived in USA. Last 13 years I'm here in India, and I work primarily on R, Python, Hadoop, Spark, Azure ML, SPSS, SAS a little bit. And our entire course is going to be revolving around these things, guys. Okay, it's going to be a 4-month course. First 3 months we'll be taking during weekdays. The last 1 month I will be taking during weekends, guys, so that we can. So that is the nature of it, guys. Okay, so just be aware of that. And that's a brief introduction, guys. So without taking much of your time, let me jump in. And today, so if you recall, last week we discussed a quick review. Keep learning, that is the mantra. An investment in knowledge is the best investment. Data can make you much smarter. World is changing fast. And data is at the heart of the change, guys. Okay, practice is very, very important. So Ritu, anybody can get into the world of data science. So these are all the questions I have also into Python or data science. You don't need to be a programmer to learn Python. I will be starting from the basics. Most likely we're going to be starting. Python is going to be the major thing that I will be covering, guys. And Vishwajit, yeah, Python, Vishwajit, that is for you, buddy. That is going to be the main batting. Rest of them are going to be bowling, wicket keeping, and fielding. Okay, because the entire world is moving towards Python because of the open source that reduces costs and things like that, buddy. Okay, so data is the heart, and this is the profession. Today is not the first class, Supriya. Today is just a technical introduction. Last week I gave a slightly more friendly introduction, much more simpler introduction. Today is a slightly technical introduction to machine learning and some of the things that you can do and what we will do. We'll try to do a couple of project-related things, and I will try to show them to you. Vishnu, type in your question, buddy. So again, some of us are doing for better career, some are for better salary and things like that. And but this is what we want. We want better salaries, better careers. But there is something else the companies want. What is it? Well, there comes the basketball, pass, catch, and shoot. Remember, they are the fundamentals. What's happening? Natural language processing, machine learning, deep learning, computer vision today are becoming the fundamentals of each and every domain, guys. Every company is trying to understand that. And by learning these things today, we are giving a present to ourselves. That is what is needed in the present. We are gifting ourselves, guys. Okay, so they are becoming the fundamentals. That is what companies want. Okay, problem. There is artificial intelligence, data science, machine learning, deep learning. Not many people there. They are the fundamentals of every domain, but not many people are available, guys. Okay, good news. Data is at the heart. Data can help you. Data can make you smart. What do we do? If you want to get into cricket, don't just learn batting, bowling, or keeping or fielding. Learn, be an all-rounder. Okay, so as part of the course, we're going to be covering these things, and Python is going to be the most prominent among all of these things. I'll go very deep into Python, and rest of them I'll give you a pretty decent introduction so that they will have a good weightage on your resume, guys. Okay, and that will also be enough. If you learn Python, you're learning one of the most complex things, and rest of them will be much more easier also, guys. Okay. So again, I'm going over these things real quick, just as a quick review. But these are the things I have discussed in a lot more detail last week, guys. Okay. For those of you, please pardon me. I will not be going over these things because I have some additional things I wanted to show. Please try to refer to the video that Sham has sent. So here is the thing. I'm gonna copy this. I'm just gonna see panelists and attendees. Paste it one more time. Please try to review that, guys. Okay. Can you all give me a quick yes, guys? If you all got that message, just type in yes. Okay, great. Thank you, guys. I appreciate that. And now today, as I said, let's come back here. One more time. Go here. There it is. So today, what we are going to be talking is, as I said, I'm not trying to scare you, but it is going to be slightly technical, but just bear with me, guys. So these are all the things that we would be learning a lot more detail in the course. in the coming up days. But we'll be starting from basics tomorrow. And tomorrow we'll be starting the batch at 8 to 9, guys. Just be aware of that. That seems to be the plan. In case there is any change, we will let you know. But most likely it is going to be tomorrow, guys. So please stay tuned, okay? So let's go into a little bit of detail. We'll talk a little bit about artificial intelligence, machine learning. ANN, DNN refer to the deep learning aspects of it. Data science is data science and artificial intelligence is a very broad umbrella, guys, okay? And before that one, let me come back here. Let's see, there's the class door. That's going to be your project. Come here. Let's see if this will bring it up. There you go, demo cricket, June 20th, workshop, demo, workshop. Okay, let me try 16 days ago, 24, running, June 27 days ago. Let me try this one, guys. Let's give it a moment. Sorry about that. Well, that is okay. So let me just say a quick hello to everybody and let me run this one. Let's give it one moment. For those of you who have seen me last week, there's going to be a lot of change today, guys. Okay, gentlemen, ladies, that is me. Cool. Last week I had a lot of beard. I had a lot of little bit of hair. I never had a lot of hair, but that's me in black and white, guys. Okay, one more time. Hello, hello, hello. Namaste. Okay, guys. Starting with a little bit of computer vision there, but that's in black and white. And let's come here. Let's try this one. Let's see if it came up. Okay, gentlemen, ladies, that's me. Cool. One more time. Hello, hello. And what is this, guys? Hello. Okay. Okay, so this is just a small technique, but we'll be learning a lot of cool techniques in the coming up days, guys. Okay. So hopefully you got a picture of me. And let's see, that is static drawing. Again, these are some of the things I discussed, guys. For those of you who missed the last week, these are some of the things here. Let me see. I think last week when I tried this one, the face recognition did not work, guys. I was at my sister's house, but today I'm back at my own home. And let's see, there you go, gentlemen, ladies, the face recognition. If you recall, last week it did not work with my beard and things like that, the background and things like that. It was not working. Okay, but today, okay, one more time. There it is. It's recognizing my face. I move, recognizes it. I move, recognizes it. Huh? Is it easier to math students? It'll be easy. I'm there, Ritu. That is what I will help you. I will help you in simplifying it. You need not be a math student. You can be a social studies or an English student also. I'll try to help you and things like that, guys. Okay. So let me see. I'll just turn my face. So notice, guys, it's not catching. Gentlemen, ladies, in your real world, they'll give you a problem like this and they'll say, hey, this is not working. We need the face recognition to be working even when somebody turns his face like this or maybe like that. See that it doesn't work. When I look at the side, it doesn't catch it. But when I look at front, notice it catches it. So this is how the things are going to look like. For those of you who saw me last week, probably there's a lot of change. My daughter forced me to do the little bit of shave and get my thing shaved off. So I've done it at home because today we cannot go outside and things like that. So fortunately I had a machine and I cleaned up myself, guys. Okay. But I hope you're all staying safe and the mantra is stay safe and keep learning. Okay, guys. So with that, that's a friendly introduction, a friendly look at myself. I hope everybody got a picture of myself, guys. Okay. So let's get into a little bit of action. Artificial intelligence is a very broad umbrella. Today, when anybody is referring to artificial intelligence, what they're really referring is not really the robotics and things like that. For the most of the time, they're referring to the machine learning, the deep learning aspects of it, making something intelligent, guys. Okay, that's what we'll be digging deep into today. So machine learning workflow, this is what we'll be focusing a lot and we'll be talking a lot about it, guys. So let's get started. The first 1 hour, it's going to be a slightly heavy theoretically. Then I will show you a couple of projects, if possible, more than two, which will give you an idea how it works. All right. So imagine we have a few cats and we have a dogs. Imagine here is Ritu. You ask Ritu, what are all the dogs? She'll be able to tell you what are all the dogs. You ask her, what are all the cats? She will be able to tell you what are all the cats. But the problem is, imagine you give 2 or 3 dogs and cats to Ritu and tell her what is a dog and a cat, she will be able to tell you. But what if you give 1 million of dogs and cats and ask Ritu to do that? She will run away. In other words, it is not complex, but it is just very unproductive. Or more precisely, it's very boring. Nobody likes to do that kind of jobs. What do? That's where machines come to your rescue. That's where we say humans fail. When humans fail, what can we do? We can bring the machine learning. Okay, what do machine learnings do? What does machine learning do? Well, you can teach a machine. Okay, imagine Ritu is a kid, and let's say, come here, back. Where is that? Here we go. Back here. Let me see if I can find my slide. Imagine Ritu is a kid, and Ritu touches fire. She learns when you touch fire, your fingers will burn. Now take Pushkar. Pushkar is a friend of Ritu. What will Pushkar do? Pushkar need not touch the fire again to learn that when you touch the fire, fingers will burn. Pushkar can learn from Ritu's experience. What is that? As humans, we learn from each other's experience. That is called learning. We are learning. Okay, what do machines do? We give data to the machines. What is experience to humans is data to the machines. What happens? We will learn. What is that? That is machine learning at a slightly friendly level, at a slightly simplistic level. What is learning? Learning is life. Why are we all here? We are trying to learn. Why? That is life. What is it? That is learning. What is learning? Learning is life. Remember, you wake up, you tell yourself, you want to learn today, you're living. Okay, so always remember, learning is life, guys. Okay, so just a friendly thing. Back to machine learning. What we generally do in machine learning is you train, you take the data, and then you build a model. What does that mean? That's what we'll try to understand today. That is called training. Then what you do is you test it. You give a group of images and then you ask your model, is this a cat or a dog? And it will be able to tell you. So training is where you're taking a group of images of dogs and cats, that is called the data. And what do? You do pre-processing, you do visualization. These are the things we'll go into in details. We'll try to go into the details today. And then we'll give it an algorithm. The algorithm will give you an output. The output is called the model. The model will now tell you, when you give it an image, whether it is a cat or a dog. That is called testing. Okay, guys. So what do we have? We have training, we have testing. It's like batting and bowling. Okay, so the model will give you the predicted output and it will tell you it's a cat or a dog. So we have the steps of data pre-processing and visualization. We have the steps of data collection. This is what we also will actually look at today in detail, guys. Okay, there is one problem. If there are only 2 or 3 cats and dogs, then Ritu can easily do it. But as I said, if there are millions and millions of dogs and cats, what will happen? Well, you have to tell, you have to label them that something is a cat, something is a dog. What happens? That is very, very laborious. That is very costly. That is very time consuming. That's where there are some tools like MTurk. They will help you. If you give the data, they will help you in labeling, in identifying the labels and things like that, guys. Okay. Google also collects a lot of data in the form from your browser and from your Android phones. Amazon is collecting a lot of data. And when you try to log in, if you recall, sometimes they give you these messages saying that, hey, can you identify where there is a person, where there is a house, where there is a window? What is that? That is also labeling. In other words, they're getting their work done by this process, guys. Okay. So in other words, that is called labeling the data, guys. Okay. There is different types of data. And we have structured data and unstructured data, guys. Okay, so let's see. Give me one moment here. Let me come back here, open this. So I come here. Scroll down. Cool. These are actually the core slides, guys, but I wanted to give you a quick idea. Okay. Here is structured versus unstructured data, guys. Okay. What is structured data? Let's come here. Take a look at this. Let's say, imagine this is Ritu. Imagine traditionally what companies are doing is they will take data of Ritu and they will save the data in their database. So let's say come here, scroll down, discard it. Okay, so now here is Ritu. What do? They will say, hey, she's a lady and it looks like she's single. Maybe she's, that's her age, 25 to 30. Maybe she's younger. And maybe that is her income. She's making $80,000 plus. What is this? This is called demographic overview. What is this? This is the kind of data they generally, come here, they generally store, let's say, in a database. This is called structured data, guys, okay? Then, but today, what is happening is there is something new. There's a new kid in the block. So let's say, come here, choose this, choose this, choose this. Who's the new kid in the block? Here's a new kid in the block. Who's this? This is internet. Internet is becoming the new kid in the block. What's happening on the internet, guys? Okay, here's what is happening. Oops, one more time. There's Facebook, there's Twitter, there is, what is that? YouTube. You have a lot of other social networking sites and things like that. What companies are doing today is they are looking for Ritu on the net. They're looking her Facebook, which is publicly available data. They're looking and seeing what she's tweeting, what she's looking at, what she's watching. They're looking at other social networking sites and so on. What are they able to understand? Imagine Ritu is a friend of Pushkar. And Ritu, let's say she's messaging Pushkar in a WhatsApp saying that, hey, Pushkar, you know what? I love to travel, man. And she's saying, hey, you know what? I subscribe to a fashion magazine, which means she's interested in travel. She's interested in fashion. And let's say she's also saying, hey, you know what, Pushkar, I took a annual health membership, which means she's into sports. And what's happening based on that? Let's say she's saying, hey, you know, I'm spending about $400 on personal care products, your hair creams, lotions, and things like that. And what's happening? They're also observing. What is happening is there is a new kid in the block. That new kid is the internet. What is special about the internet? On internet, the data is called unstructured data. Generally, what companies do, when companies go to database, they save the data of a customer, they save very limited data. From this one, to be able to understand more about Ritu, there is not much available. Okay, you understand she's making $80,000 plus. This is her age, but you don't know that she likes to travel. If you know she likes to travel, what can you do? The next time she goes to Google, what will you do? You will give her an ad about a travel, maybe from New York to Paris, Paris to somewhere else, and so on. Maybe these days we'll slow down on travel, but looks like she's also into fashion, which means if she doesn't select a travel ad, let's give her a fashion ad. It looks like she's also into sports. So what do? Well, shoot her a Reebok or a Nike shoes. Why? She's into sports. And what is it? She's spending $400. What is it? These are the kind of insights we will never get from a database. Okay, what is database? You can think of database as the rivers of the world. And what is water? Water is like the data. There's only 10 to 20% of the water in the rivers of the world. 80 to 90% of the water is in the seas and oceans. What is that? That is the internet. Today, every company, what they're doing is they want to understand people like Ritu, or in other words, every person they want to understand. What is happening? If about Ritu, we are able to understand so many insights. Imagine millions and millions of customers, how much we can understand. What is that? That is what people are after. Or in other words, that's what the companies are after. What are these? These are called insights. What is this? This is called unstructured data. This is also formally referred as psychographic overview. Okay, so Now, that's a quick example. Let's come back here. Structured data is generally stored in the form of database tables in the database, guys. Okay. You have data like zip code, current date, your designation, salary, and things like that. That is generally structured data. It's only 10 to 20% of the data. But what is unstructured data? Unstructured data is your images, your videos, your information, your messages. And what are we doing? We're using techniques and tools like natural language processing. And we are trying to get insights from them. What does Ritu like? What should we show her? What should we target her? What should we sell her? And things like that, guys. They don't have a structure. Imagine Ritu is sending a message to Pushkar. She's saying, hey, buddy, I'm traveling. I love to travel and things like that. There's no structure. That is plain text. There's no structure. It is generally not stored in a database. It is stored in something like a NoSQL database, guys. Okay. So, and searching it is difficult, and processing it is difficult. And again, similarly, image and video data are binary data. They're also referred as unstructured data, guys. Okay. So let me come back here. So that's a little bit about structured and unstructured. We'll talk more. Then we also have a step called feature engineering, which is one of the most complex, innovative, and creative steps in the world of machine learning, guys. Okay. But before we go into feature engineering, here is a touch of what is called pre-processing. Many times we have data. Cool. So in other words, let's say, come here, take a look at this one. Start with Glassdoor jobs. Take a look at this. This is the project that we'll be doing today. Imagine, scroll all the way down. I have downloaded 1,000 jobs from Glassdoor. Okay, we have a job title here is data scientist. Notice salary estimate $53,000 to $91,000, and that's for a data scientist. They're looking for a data scientist. Here is a pretty big description. I think if you this guys, some of them have given some very brief description. Whereas notice this fellow has given a pretty big description. Rank number 1, it is no B4 and things like that. Then let's say, let's move this a little bit here. Here is the rating. What is rating? Well, sometimes we may be able to understand. Maybe this is the rating of the company, which is Tico Load. That is the company which has posted this job. Albuquerque, I think this is in USA. I think today what I did was I downloaded all the jobs from USA, but we can also download from India. And they're headquartered in California. Looks like they have 500 to 1,000 employees. 1973 is when they started. It's a private company. They're into aerospace and defense. And there's the sector again. They make $50 million to $100 million. That is their revenue. Then they don't have any competitors, or they did not give any competitor names. Maybe because they're into defense, they did not give any competitor names. But some of the companies they have given. Here are the competitors. Oak Ridge National Laboratory. This is the government company. They're in Richland, Virginia, and so on, guys. They are also looking for a data scientist. So totally we have 1,000 data scientist jobs that I scraped today to show you guys how we work with and things like that in the towards the end, guys. I will save that a little towards the end. So what do? We take that kind of data, and what do? We clean the data. There might be some places where the data is missing. There might be some places where the data is not in proper format. If the data is missing, what do? By discarding data, you're losing some value. If we delete the data which is not proper, or if it is missing, we might lose some information. What do? By imputing. If the data is missing, you impute. Impute means you substitute. If you substitute, you may end up substituting wrong values. What will you do? And then data transformation. How do you scale your data? How do you standardize? How do you use different kinds of methods, tree-based methods and things like this? Is all what is called pre-processing. After pre-processing, we take the data, we build a model. We build a model. The model can predict if Ritu will get the next job or not. We can build a model, and we can make the model predict what salary Ritu might get in her next job. Those are the kind of things that we need. But if we go back one more time to our data, there might be, so take a look at the first column. This is called ID column. Imagine we want to predict if Ritu is going to get a job or not. And she's applying for a lot of data scientist jobs. Here are the salaries. If you take a look at an ID, let us say you take the ID of a job and you're using it to predict the Ritu. If Ritu is going to get a job or not, that is not really meaningful. So what is it? That is called a feature. That is a feature which is not important, which is not useful. What do? Well, You can use maybe job title. You can look at the job description. If she's applying for a data scientist and you're applying for a software engineer, then you can say, hey, this is for software engineer, not for data scientist. So in that case, we say job description is a feature which is important. Okay, then you have rating. So some of these things are important. Some of these things are important. What is that? These are called the features. If you take an image, a cat or a dog, okay, images can be, this is a data which we can understand. But if you take the image behind the scenes, it is nothing but binary data. We will not be able to understand. We can define an image as a group of pixels. Both are pixels. Even though both of them are dog images, what happens? They are completely different. At a mathematical level, they're nothing but matrices and numpy arrays, guys. Okay, so they cannot be compared directly. In other words, at a mathematical level, they will be different. So this is how the data might look like. When we learn computer vision techniques and things like that, these are some of the concepts we learn. We can represent a dog like this dog, using this data, and this dog using this data. These are called features, guys. Okay, then we have visualizations. We take our data, we do lots of visualizations and things like that. That also we'll have a look at that, guys. Okay, then comes the machine learning. So this is where the main modeling starts, guys. Okay, so now take a look at this one. You have two columns, x and y. If you notice, both x and y are same. What we are saying is, think of mathematical relation that exists between x and y. What does that mean? Take a look at this. We can say y equals to x. This is a simple example, but take a look at this one. X and y one more time. Now notice x is 1, y is 2, x is 2, y is 3. Notice it looks like y is always x plus 1. What is that? That is a mathematical relation. Okay, so we are deriving an equation from data. This equation is called a model. Being able to get a model, get an equation or derive an equation like that is nothing but modeling, guys. Okay, now take a look at this. Imagine we gave this to Ritu, and x is 1, y is 10, x is 2, y is 20 means it looks like y is 10 times x. Again, we gave the data and somehow we are coming up with an equation. Take a look at this one, x1, x2, and y. What do we have? Well, if you add x1 and x2, you get y. So what do? We can say y equals to x1 plus x2, roughly. Everybody with me, guys? But take a look at this. If you have 100, if you have 1,000, if you have 10,000, or if you have 100,000 variables like that, and you ask Ritu to come up with an equation like that, what can happen? It will become very, very difficult. It might be very, very complex also. Okay, so what do? That's where we bring in the machines. Give the data to the machine will derive the equation. Everybody with me, guys? What is that? That is called machine learning. At a slightly, that is one perspective. What machine learning, this is what is called model. This model, who's Ritu? Ritu is, one of our students, buddy. Ritu is the other girl who joined, who was asking the questions. So I'm referring to her just to make it easy, Ravinash. Sorry about that. I'll take your name instead of Ritu so that it'll become easy for you. Okay, buddy? Just kidding there. Gentlemen, ladies. So there is cat. At a mathematical level, we will later look and understand a cat is nothing but a matrix. This is called a matrix, a two-dimensional array and things like that, guys. Okay, what do? These are called the features. Now, what will we do? You take this data, you give it to a machine, it will give you an equation. That equation, you give it an algorithm, that algorithm will give you an equation. This is called deriving an equation from data. That algorithm can be used to find. Now, in other words, that output or the model, we can now use it. And if you give it a image of a picture of a cat or a dog, it will predict if it's a cat or a dog. That is generally what is machine learning, guys. Okay, so that is again a slightly high level look. Going a little bit more deeper, machine learning is finding such complex mathematical relations between x's and y's. What we looked at is simple scenarios. Y equals to x, y equals to x1, y equals to x times 10, y equals to x1 plus x2. These are simple scenarios, but in real world, the data will be very, very complex. What do? Humans fail. We cannot do anything. When humans fail, what do? Bring in the machines. What do machines do? Machines will do the complex mathematics, statistics, and probability. They will give you the equation. What do? You take that equation, you make the predictions. Okay, guys. So machine learning helps to find hidden insights. Those models help us in finding hidden insights. Okay, and input to. So again, they're generally referred in the form of X and Y's. That's all. That also we will look at. If you take a look at Google, Amazon, Facebook, and Microsoft, guys, these are the emperor, the king, the queen, the gladiators of the today's world. Indirectly, they are the greatest and the latest companies of the world. What are they? The secret, they are the most successful organizations. What is behind their success is machine learning. Everybody with me so far, guys? Can you give me a quick yes, please? Are you able to understand what I'm saying, guys? Everybody okay? Cool. Okay. So again, if you're finding it a little bit too technical, just forgive me, guys. As I said, please try to refer the previous one also. And in the coming up days, these are the concepts I will help you simplify and understand in much more detail, guys. Okay. So what is happening, guys? The AI box, what is that? That is what is algorithm. It's a group of algorithms. What do? They take the data as input, they give you the output. The output is the equation. The equation is what we call the model. The model is what will help us in making predictions, guys. Okay. So what does that do? That does complex mathematics, statistics, and probability. Remember the mantra. If you want to drive a car, you don't have to be a mechanical engineer. What will you do? To drive a car, turn the key. What's happening inside the car? The petrol is getting converted to electricity. As a driver of the car, you don't need to worry how the petrol is getting converted to electricity. What do? Have an idea. So, as a data scientist, what are we? We are like a mechanical engineer. What do? We have an idea of the complex mathematics, statistics, and probability. Those are the concepts that we'll be looking and we'll be trying to learn in the coming up days, guys. Okay. So, in the coming up days, I may have briefly explained in the previous session, lots of jobs are going to be taken away by the robots, guys. Okay. So, let me come back here. Back here. Cool. Scroll up here. There you go. It is cheaper to buy a $35,000 robotic arm than it is to hire an inefficient employee who's making $15 an hour bagging French fries. In other words, that's coming from the McDonald's CEO. He says it is much more cheaper to buy a robot than employee is what it means. In other words, he's indicating that it's going to be automated. Robots are going to be taking over. Okay. The only answer to job loss is universal basic income. I'm sure you have all heard about driverless cars. What is happening? In a few years, it is going to become a reality. And when it becomes reality, all the drivers are going to lose their jobs. So what do? United Nations is proposing if anybody loses a job because of a robot, let's give them some basic income so that they can survive, their family can survive. That is under process. Probably it will take 5 to 10 years in India where when the driverless cars will come in, guys. It has many advantages. The only disadvantages that the drivers may lose their jobs, guys. Okay. An ATM of tomorrow will be able to do 90% of the work of a teller. Teller means the bank employees and things like that. And ATMs today, not tomorrow, can do 90% of the jobs that the bank employees are doing. What does that mean? The banks are going to replace the employees with the robots. Farming. Today, if you go to village side, if any of you have relatives, friends, and things like that in your villages and things like that, many times when I go to my family, they keep complaining. We're not getting enough labor. Government is giving many things cheap. People are not coming for work. The labor is becoming expensive and things like that. There's a lot of shortage of labor. Good news, that's where robots are going to come in. They're going to help us in agriculture. That's a good one, guys. Okay. Journalists, 80 to 90% of the work that the journalists are doing today will be replaced by robots. Cool. Not one job, not two jobs, but every job is going to be replaced by robot in the coming up future. I'm not trying to scare you, but there are many other things that we'll be discussing, guys. Okay. So that is what we mean. Lots of jobs are going to be replaced. So what is going to happen to all the humans, guys? What is going to happen is we will have jobs. How we will do the jobs is we will do the jobs with the robots is what's going to happen. It is not that the robots are going to steal our jobs. Again, last week I gave some good examples how you can imagine a world without any disease. What's happening? Using AI, they are predicting in the next 10 years who's going to get a heart attack. University of Nottingham, Today, they're trying to use the same concept across many, many diseases. So what will happen? The world will become free of disease. What is that? That is artificial intelligence. Imagining a world without any disease is just super cool, if you ask me, guys. Okay, so AI is going to do things like that. It is not coming in to steal our jobs or things like that, guys. Okay, so again, I will not go too much into detail, but I'm just refreshing your brain there, guys. So artificial intelligence, some complex intellectual tasks are performed by humans can also be performed by machines. What does that mean? Well, there are three images. If you want to go ahead and identify what each one is, well, there's an ant, there's a monkey and a lion. What can you do? You can use artificial intelligence. What is artificial intelligence doing? It is at a mathematical level performing what your brain is doing. That is where the neural networks come into picture. Chess is one of the most complex games in the world. You need to use a lot of brain power. You need to be very, very intelligent and clever. What happened? Well, that is where artificial intelligence has started defeating the humans. Gary Kasparov was defeated by artificial intelligence, guys. Okay, so ideally, what will happen, guys? If you want to play a chess game, if you want to write a program, we will write a lot of rules. What's the problem? If you start coding a lot of rules, what can happen is there might be infinite number of such rules. What will happen? It is not possible for us to write that many rules. That is where artificial intelligence can come in. Whenever I refer to artificial intelligence, you can kind of think of that as machine learning. Today, machine learning is indirectly referred as artificial intelligence, guys. Okay, so I'm kind of using both of them as interchangeably, although machine learning is the heart of artificial intelligence today, guys. Okay, but think of it like that. And that is where, for that kind of programs, we use machine learning when you have infinite number of rules, guys. Okay, so here is, let's say, okay, I will not bore you, but there's a computer program. Generally, to write a program, we write a set of rules, we give data, and then we get the answers that will decide, hey, if this is true, what will happen, and things like that. But what will happen in programs, if you have to write a program like a chess, what is it? It's a super complex program. In other words, it's a program where humans will almost fail. That is where the machine learning and the AI will come to our rescue, guys. Okay, today's world. Oh, Rajesh, lots of things are there, buddy. Again, you can, yeah. So because Rajesh is asking me, give me a business example. Imagine there are a group of students here. Now, some of the students are going to be joining my course. Some of the students are not going to be joining my course. I can build a model based on your data. I can build a model and predict who is going to join my course. How will we do that? I'll give you a touch of it. That's what I'm going to be waiting. Okay. Imagine you're a bank. Imagine lots of customers are coming in and they're asking for loans. What does bank want to do? A bank wants to predict who's going to pay the loan or who's going to default. In other words, they want to predict who's going to default. If they're going to default, then they don't want to pay the loan. What do? That is where we will use machine learning, guys. Okay, so here is some traffic data, but let's say let's give it a moment. Here is some banking data. Take a look at this. Here's a customer. This is the credit amount he or she still needs to pay to a bank. And purpose credit taken. I think she has taken for home loan, 11 months duration. That is her status checking. I think she has a credit history. That's just a code. Then it looks like she's a full-time employee. She's been working for 5 years. Because I have an idea of the codes, I'm reading it loud. Take a look at this. Maybe I think she's married. A93 means she is married. Next, she has not given any guarantors. She's been living at her house for 2 years. Her age is 40. She has her own house and it looks like she also has 2 credit cards. What is she? She has 2 dependents. Maybe that's her husband and a child, or maybe that's her 2 children. Is she a foreign worker? No, she's not a foreign worker. In US and Europe, they track if somebody is a foreign worker or not, guys. Okay. Did she default? No. 0 means no. Take a look at this customer. This customer defaulted. What is it? We have totally 5,000 rows, which is like 5,000 customers data. You take this data, you build a model, and then the model can predict when a new customer comes in. Imagine Preeti is a new customer who's coming in. We can predict if Preeti is going to pay the loan or not. What is it? That is what data scientists do. That is what is data scientists. And Preeti says in education sector, imagine, I'll show you an example today, Preeti. Imagine you have a group of students. You can predict if a student is going to pass or fail. You have their marks. That's what we'll do today. A simple example is that one. A more complex example is another one. And imagine you want to predict what score a particular student is going to get. What can you do? You can predict it. Getting it, Preeti? Can you give me a quick yes? So these are some of the examples of the case studies that we'll also be doing as part of our course, guys. In embedded, okay. In embedded system, I think if you're, I don't know if you're related to sensors and things like that, buddy. So Shubham. So if you're into sensors, you can predict, when sensors are going to fail. Are there any anomalies? The temperature has to be of a sensor has to be between maybe 30 and 33 degrees, but suddenly sometimes it goes to 40. Can you predict it? We can predict it. Okay. How do you predict the scores? That is what is modeling, Preeti. So if you go back to a few slides before, your X's, X1, X2, X3 are your marks of the student. Y is going to be the score of the student, Preeti. Cool. We use the machine learning algorithms. That is true. Okay. So, okay, because a lot of you are asking me a similar question, and because Preeti has also brought up similar thing, let me quickly jump in here. Let me jump in here. Let's go here. Okay, this is Jupyter Notebook, guys. This is what will be. This is one of the tools, development tools that we'll be doing our course, and it's a very popular tool. A lot of data scientists use this, guys. Okay, so let me bring this up. Go ahead and run this one. I'll quickly run this one. And let's see, let me show you what we have here. Close this one. That's opening there. And there you go. Okay. So, okay, take a look at this one, Preeti. Let me run this one. What I'm doing is, this is called a cell. I do a shift enter, and it is reading a file. Now, what is a file? For a moment, don't worry. But here is what is in the file. We have study hours and we have the student marks. Take a look at this student. Okay, running again. Give it a moment. As per their practice and time spending, how is it? True. Performance of the user changes. True. Okay, so let's see if this will give you a little bit of light, Rajesh. Here is, imagine this is Preeti. She's studying 6.8 hours a day. Her marks are 78.5. Let's say this is Rajesh. He studies only 6.5 hours a day. He got 76 marks. For some reason, let us take Manish. Manish, we don't have his study data, but he got 78 marks. Then we have, let us say, Shubham. Shubham is studying 5.6 hours a day. He's scoring 71 marks a day. I'm sorry, he's scoring 71 marks, or that's what he got. Like that, what do we have? There are some students, we have their marks and how many hours they are studying is what we have. That is called head. The head will give you the top 5. The tail will give you the last 5. Let's say this is another group of students. We have their study hours and student marks. Okay, so this is going to be X, this is going to be Y. Give it a moment here. Running. Okay, so if you take a look at shape, there are 200 students like that and 2 columns. For 200 students, we have taken how many hours they are studying and how many marks they are getting, guys. So let's give it a moment here. Wonder why it's running so slow. Come here. Let me see if I can close this one. Minimize this. Still running. Okay. Okay. So there it is. The tail will show the last 5. These are the things in detail I will explain the coming up days, guys. But for today, let me just give you a quick idea. Allow me, if you, just to give you an idea. Shape is telling, hey, this is called a data frame. Data frame is a Python object. This is a Python syntax. It's telling you there are 200 rows and 2 columns. Info. So when you do info, it gives you what is called metadata. Notice study hours. It says 195. It looks like there are totally 200 rows or 200 students, but only the info is indicating there are 195 study hours, which means out of 200, 5 are missing. So what is that? That is missing data. So what is that? That is what info is used for. We try to understand if the data is missing. For student marks, we have all the marks of the students, but for some students, the hours are missing. That is called missing data. Then you do a describe. This will give you what is called descriptive statistics or basic statistics, guys. So it looks like minimum is 5, means students in the data that we have, students are studying anywhere from minimum of 5 hours to maximum of 9 hours, close to 9 hours. On an average, it looks like students are studying about 6.9 to 7 hours. Okay. And if you look at the student marks, minimum, it looks like minimum marks the students are getting is close to 68 point something, which is like 69 marks. Maximum is up to 86.9, which is 87. On an average, they're getting 77. I think that's a pretty good class, pretty good group of students. So that would be my take. And now here is a touch of visualization, guys. Okay, generally we've been saying, hey, we visualize the data. So what is happening is, one way we can explain this is, come here, take a look at this. We have student marks on the y-axis, student hours on the x-axis. And what's happening is, notice the flow of points seems to be in the direction. This is called positive correlation in machine learning or a data science world, guys. Okay, what that means is, if you take any point, let's say you take any of these points, what's happening? Not only their x-axis value is high, their y-axis value is also high. Okay, so what is that? These are the students where the hours they studied is high. How many hours they studied is high. Okay, and what is happening? They have marks that they're getting is also high. These are the students where their x-axis is low. How many hours they studied is low. How many marks they're getting is also low. So in other words, we can roughly translate this visualization and say, it looks like when students are studying more hours, they're also getting higher marks, is what we can translate it into. If they study medium hours, they're getting medium marks. These are all the medium guys. So what is it? That is called correlation. Okay, so in other words, we say the students' marks are correlated, they are positively correlated, is what is a technical concept there, guys. Okay, so in the eyes of a data scientist, that is called a positive correlation. Now, this is how we verify, are there any students, there are null values, is null is indicating, hey, in this column, study hours is null. There are 5 values where we do not have the study hours. How to give the label here? Raj here, Rajshri, the label is the marks. This is a regression, just in case you have an idea. It's a little too early to talk about those things, but your label is the marks, Rajshri. And mean is telling you, hey, on an average, looks like students are studying about 6.9 hours and they're scoring up to 77.9, which is up to 78 marks. What is it? This is what data scientists do. We're not writing one huge tens and tens and tens of lines of code. Every one line of code is telling us something which is informative. It is not the greatest insight of the world, but it is giving us some kind of insight into the data insight about the students and things like that, guys. Okay. These affect our linear regression. True, Manish. So we'll see if we're fixing that. So in the next step, generally the process is what Manish is asking. When we have some missing data, you build a model. What did we do? We can build a model. The model will be will give you prediction. But a good practice is when you have missing data, if you can fill up that missing data and then build a model, then that will give you a much more better prediction. So what do? You fill it. What do you fill? You use the mean, you use the average. Why? Again, that I will save it for a later day. So technically, for doing this data prediction, use these functions, true. Not only for this one, Preeti, for any of the modeling, these are the techniques that we generally follow. Based on a domain to domain, based on the requirements, the things will be a bit more complex. Okay, Preeti? NA and data. It's too early to talk about NA and Manish. There are a lot of guys who do not understand nulls and things like that, but we pre-process the NA and data is true, buddy. Cool. So again, so what do we do? This is, we're saying fill it with the mean values. Then again, you verify. Notice study hours has become 0. So what is this? This is called pre-processing the data, what Manish is referring, guys. And let's see, again, that is we're verifying the data there. And now this is what the X and Y. The X is going to be the left-hand side. What is that? This is the data. And what do you do? Y. This is called the independent variables. These are called the dependent variables. You divide your data. How many marks? How many hours? Why is the drop? I'm dropping it. Okay. So in other words, we are separating the X will be the hours and Y will be the marks, guys. So even though what we are doing is we're doing a drop here. Okay, you don't generate the formulas. The algorithm will generate the formulas, Preeti. Okay, so how do you do? Well, your first step is separate the data of your marks and hours. Then what you do? You partition the data. This is called partitioning. I will see if I can explain you conceptually, but for sake of simplicity, you imagine we are doing something called partitioning. Then we're building a model. You create an object, you fit it. This is where you're giving the data. This is where you're giving the data to an algorithm. And what will it do? This is the output it will give you. It'll tell you for every 1 hour, for every 3.9 hours, okay, 3.9 hours, that a student is studying, it looks like the students are getting 10 marks additional. Roughly, guys. Okay, not 10 marks, but I think maybe for every 3.9 hours, their marks are increasing by 10 marks is, I think, what I recall. I'll need to actually look at the summary. M is 3.9, C is 50, M times 4, Y 66. So for every 4 hours they're getting studying, they're getting, pardon me, 66 marks is the meaning of it. This is called interpreting the output of the model. Again, these are all slightly advanced techniques, but the objective here is in presenting you that this is the work that data scientists do. Tomorrow, as part of the course, what you will be learning is you will take any data and every data. You will be performing analysis in this format, in this way, and this is how you'll be building the models. There's a much more cool project I will show you in a bit, guys. So just stick with me, be a little bit patient, and pardon me if this is looking too technical, but that is what do you do? You predict it. You're telling it, hey, here's a predict function or a method. You're telling it, here is a student who's studying 4 hours a day. Tell me how much he's getting. It's saying, hey, he will roughly get 66 marks if somebody is studying 4 hours a day. Okay, you can give it 5 and it'll probably increase by something. So I think for that, I need to run these things. I stopped running somewhere over here. Let me come here. Here's shape. Give it a moment. Let's run it. I'm doing shift enter. In Jupyter, you do shift enter, guys, to run these cells. Let's give it a moment. Pardon me. Sorry about that. Scroll down. So where am I? There. Okay, I'm gonna run this. I'm gonna run this. Predict in this built-in library. Predict is a method or a function in the library called scikit-learn, Divya. Okay, scikit-learn is the Shah Rukh Khan of machine learning in Python. That is what we'll be looking at. We'll look at 2 of them, scikit-learn, TensorFlow, and another one is stats models. Let's run it. Let's run this one. Run this one. So it's going a little bit slow. Bear with me, guys. I have too many applications open. That is also one of the reasons. Here's the coefficient. And this is what companies want. Why are all these things important, guys? Companies have a lot of data, but they don't know how to build the models. That is where they are asking you to come in. By learning these techniques, we can be useful to the companies. That is why we are learning these things, guys. Okay, so now I'll change this to, let's say, 5 hours. Let's run it. Let's give it a moment. 70. If a student studies 5 hours, okay, a day, he will get 70. Let's say he studies 6 hours a day. How the data imports Excel to Python. We'll see that round. There are built-in methods and functions. So coming back here, if a student studies 6 hours a day, he will get roughly about 74 marks is what it is. What are we doing? We are now predicting based on the study marks, but you can add more data. How many marks? We are doing a project for one of our clients. And what the client wants to understand is if the students' parents are married versus if they are divorced or if they are educated. What if both parents are educated? What if one parent is educated? Is there any impact on the students' marks? That is what our client is asking us to do the research, guys. Okay, what is it? That is what you will be doing in real world. That is how the projects will be looking like, guys. Okay, so that is one example. Generally what we do is we use joblib. Here is joblib. You take that model, you save it to a file, and then you can pass on that file to your other Python GUIs and front-end teams, and they will take this file and they will start make predicting. So here is again one more time prediction. So this is a syntax of the NumPy arrays and things like that, guys. We did not go into the details. It's not the we'll learn those things in the coming up days. So again, one more time, some other application is loading up that file and saying, hey, if a student is studying 5 hours a day, he's likely going to get 70 marks is what it is. You can cap it, Abhishek. That is called capping and things like that. So here is our next one, Glassdoor job search. You'll find this useful to you. These are the projects we'll be doing as part of our course, and I'll be sharing it in the course, guys. I know one of you are asking me if I can share these things. We'll share it as part of the course, buddy. So just bear with me. That is discipline and things like that. Hope you understand that. So I'll save the job search here for a moment. And now take a look at this, guys. So let me come here. This is numerical data. Let's say our data sets. Now come here. Let's say sort this one. Scroll up here. Here is convolutional neural networks. More precisely, let's go back here. Here is images. Take a look at this. Cell images. Then we have, here is what is called parasitize. Take a look at this. There are close to 14,000 images. Notice these are the images of the cells with microscopes, with some specialized microscopes and things like that. Pankaj, please, our support team will be sharing the material and content, buddy. Allow me to focus on this one. So take a look at this image. This is an image of a cell where there is some bacteria. It is parasitized, means there is some parasites in the cells of this person. And let's go to another one, another cell. Notice there is some presence of some foreign elements is what it is in terms of biological terminology, guys. Okay, so if a physician looks at a microscope and looks at marks like that, that means these guys have malaria. There's something wrong with their cells in the body. But take a look at this one. Go back to cells, uninfected. Double click this. These are uninfected cells, guys. Okay, so now take a look at this. Cell is clean. And let's say go to the next one. Go to the next one. Next one, notice they're all clean. Okay, so what is it? Now, this is called image or binary data. What do we have? I have cell images in parasitized and uninfected. Today, the concept is the same. They're also, you can think of this as all the images of the guys. Today, what they're doing is they're taking the images of the x-rays of the COVID patients. And what will COVID patients have? Just visualize an image of a COVID patient where, imagine this is an x-ray. One more time, I'll open this one. And on the x-ray, what they will do, they will see some presence of some foreign elements somewhere in the x-ray. I have it somewhere, but I did not open it. I just need to search. And if that presence is there, that means they have COVID. And again, if an x-ray looks plain without any presence of foreign elements, that means they do not have COVID. What are they doing? We take this kind of data. The student marks and study hours is kind of, readable data. It's like structured data. This is unstructured data. What do? We can also build models based on this unstructured data. You take this data, you build a model. What do? You don't do the thing. The algorithm will do the thing. What will it do? It will do the complex mathematics and statistics. What will you do? You will use that model and you can predict if somebody is having malaria or if somebody is having COVID and things like that, guys. The concept will remain same, but the data will be different. Okay. So everybody catching that concept, guys? Can you give me a quick yes, please, before I answer your questions? Are you catching the concept, guys? I'm just explaining the concept of what are all the things which can be done here. I'm not expecting you to be perfect or anything, but these are the things I'll be explaining in the coming up days, and I'll be teaching, guys. And these will become easy for you. That is what the companies want from you. Okay, guys. And then they can make use of you, and they can have you help them in their companies. These images can also be read for data prediction. True, Preeti. How can we learn this? Take my course, Ritu. Just kidding there. You can learn on your own, but you'll struggle a little bit. If you don't want to struggle, take my course. Just kidding. Huh? You can take any course, Ritu. This is a good course. This is a course which will be useful to you throughout your life. It's not just 1 or 2 days. So definitely give a little bit of time, little bit of energy, and little bit of budget to it, Ritu. It is worth it. How to learn these different functions? Take my course, Divya. Just kidding. Same answer. If you don't want to struggle, take my course. Again, just kidding there. So let's see, just join the webinar. Provide. Okay, I think I answered that question. Let me come here. Even more TV channels can be data. Yeah, good ideas there. Innovative ideas there coming up. Yeah, you can make the TV channel. Streaming TV streams also can be manipulated. That will come under computer vision and things like that. Mechanical engineering joins software side. What type of course learn? Learn data science, Vishnu. Okay, it's one of the best things. It's not because I'm teaching us. Data science AI today is everywhere. And Vishnu, if you have not attended the last time also, please check out that one also, buddy. Okay, so let's see. Back to, where am I? Here we go. On this one. All jobs, here we go. And let's see where we are. Okay, 10:19. So the next few minutes, guys, I will go over a few more slides. I might bore you a little bit, but just bear with me. After that, I'll take you through another kind of an example or a case study or a project of a data science, which you might find helpful and useful to you also from a personal perspective. That is the Glassdoor jobs thing. And so bear with me. So before we proceed, allow me to just take a couple of minutes break here so that I can have a breath and a glass of water. So gentlemen, it's right now 10:20. Let's take a 2-minute break if you're all okay. Is that okay, guys? Everybody okay with that? I'll just do a little bit of water and things like that. So just relax, step out and relax. And let's take 2 to 3 minutes break and we'll be back. I'll keep this on and I'll come back and we'll proceed from here, guys. Thank you. Take a 2-minute break and be back. Okay. Sorry about that, guys. Can you hear me, guys? Ritu, can you hear me? Thank you. I appreciate that. Thank you, Ritu. Preeti, sorry about that. I was just having a glass of water and trying to get some energy here. So let's see. Python are same or R is on upper level? Python, yeah. If you learn Python, R will become easy. If you learn R, Python will become easy, Ritu. But we'll start with Python, then we'll slowly step into the world of R. Ram, what function will have the algorithm look like? It for C program, from C programming. Python, what function, and it will have algorithm like. Okay, so again, it's like an object, Ram. I'm slightly confused with your question, but when you create a model, it's like a Python object is what it is, buddy. SPSS and SAS are used in commercial organizations, Rajeshri. So it will also have you um, get some advantage if you have an idea about them. Okay. Shows the syllabus of the class. Yeah. For freshers also, it is pretty good, guys. As I said, machine learning, deep learning, computer vision, and natural language processing, irrespective of an IT company, irrespective of an IT department in a company, every company can have an analytics department. It is not necessarily an IT department, but it's an analytics department where they will take different kinds of structured and unstructured data and they will analyze. And more importantly, Amol, these are all becoming the fundamentals. Every domain is trying to, every company is trying to understand these things. So if you're a fresher, if you have these things, the value of your resume will be a lot higher, is what it is, buddy. Okay, so I'll show you towards the end, Abhishek. Just bear with me, buddy. So let me continue a little bit of journey here. Imagine we have to write a program, and the program has to detect when a person is saying yes or no. Run in Tomcat and Python. Okay, so if we have to write a program which will just detect, whether person is saying yes or no for the words yes or no. Imagine what we are doing is we are looking at the pitch, we are looking at the duration of the words, how much time these words are. Based on the duration, let us say here our program is saying this is yes or no. That is okay. But what if we have to write for 100 words or 10,000 words? What will happen is it will be extremely difficult. It will be extremely complex. It is not easy. That is where machine learning comes to our rescue. What is this? This is speech recognition. What is it? That is also binary data like the images and the videos. And what do? Well, that's why the machine learning comes to our rescue. It will take the data and it will learn from the data. To be more precise, it is not the machine which is learning, it is we who are learning. We say it is machine learning, but machines are doing the complex mathematics and statistics and probability guys. And then what do? We share the knowledge. We use the knowledge. That is machine learning. One more time, we have a group of images. What is that called, guys? I forgot the name of that animal. That's not, here's a cat, here's a lion or a tiger. I don't know if any of you remember the name of that one. Ideally, what we do is you take the pictures, you give it to a machine learning algorithm. The algorithm first understand it looks like a wolf, but not a wolf. Sarthak. Hyena. There you go, Preeti. Good one there. So an algorithm will try to understand what is a dog or a cat based on the group of images. And imagine there is a kid. If you want to train a kid, what is a hyena versus cat versus a lion? What will you do? You'll take a group of books, then you'll tell them, hey, this is hyena, this is cat, here is a dog, and maybe a cheetah or a cat, and things like that. That's what you're doing to a kid. But what do? The same thing here. What we're doing is instead of the books, the images is our books. The images is the data is our books, and you give it an algorithm. The algorithm is acting like a kid. It is understanding what is a cat versus dog versus hyena versus a lion or a cheetah. And what is it? That is called training stage. Okay, this is called supervised learning. Supervised learning is where we are telling what is a cat versus what is a dog, guys. So here's a dog, here's a cat. This is called supervision. That's a slightly high level understanding of what is called a supervised machine learning. This is called labeling, saying that this is a dog, this is a cat, this is a dog is called labeling, guys. Okay, what do? You give it an algorithm and it understands. It's understanding like a kid. And what is this? This is called training. Then you take an image. Everybody okay with the sound, guys? Can you just type in yes or no? Ankur seems to be having problem. Okay. Okay. Thank you, Ritu. Thank you, Pushkar. Ankur, please check it your end, buddy. Okay. Thank you. So once the algorithm is trained, guys, what you do is you take an image, you give it to an algorithm. The algorithm will predict if it's a cat or a dog or a hyena. That's what is machine learning, guys. Okay. Then we have deep learning. Deep learning are complex algorithms. Think of artificial intelligence as cricket. Learning how to hit the force in the cricket is machine learning. When you hit the force and you cannot win, what do? You hit the sixes. What is hitting sixes? That is deep learning. When humans fail, bring in the machines. That is machine learning. When machine learning fails, bring in the deep learning. If you cannot hit the force and win the game, hit the sixes and win the game. What is that? That is deep learning, guys. Okay. Deep learnings are a set of advanced machine learning algorithms. They do more complex things. They need more computing power. They work in the form of neural networks. This is an example of a neural network. We have an input layer. The blue is the input. The green is the hidden layer. The orange is the output layer. We can have one layer. You can have two. You can have 100 layers like that. The more the layers, the more the deep. It is called deep neural networks, guys. Okay, that is what is deep learning. If we have only one layer, that is called shallow learning. Remember, if you need a hammer, don't use a screwdriver. If you need a screwdriver, don't use a hammer. What a butterfly can do, a cheetah or a lion cannot do. What a cheetah or a lion can do, a butterfly cannot do. When it is time to use a butterfly, don't use a cheetah or a lion. When it is time to use a cheetah or a lion, don't try to use a butterfly. In other words, sometimes algorithms or the models with only one layer will work, but with many layers don't work. What do? Use only one layer. That is called shallow learning. When you have less number of layers, they are called shallow learning. They are not bad. It is just that sometimes they work. Sometimes you need neural networks with hundreds of layers. They are the cheetahs and the lions. What do? When you need to use cheetah and lion, don't use a butterfly. That is called deep learning. Okay, slightly at a high level, that is what is deep learning. They are complex. They need very highly sophisticated hardware or a more heavyweight hardware, guys. Okay, so they perform more complex tasks than machine learning. Okay, so what is slightly kind of something to be kept in mind is, why are we talking about machine learning and deep learning now? Why not about 10, 20, 30 years ago? What was happening 10, 20, 30 years ago? Machine learning was there. Deep learning concepts were also subtly there. They were existing. But today, what is happening? Data is everywhere. Data was not everywhere about 10, 20, 30 years. One of the reasons, internet. We're all connected, guys. Okay, the data is available, the data is stored. And what's happening? Because the data is available, every company is trying to find the patterns in the data. That's what companies are trying to do. That's where they need you. Okay, a bottleneck earlier, about 10, 20 years back, what was happening? The hardware was not cheap. There is something called CPU and GPU. Our laptops are CPUs. GPU is like a CPU with 2000 CPUs on it. That's a very powerful device, guys. Okay, what can we do? We use that kind of GPUs in gaming software and slightly heavy, computationally heavy things, guys. Okay, so for deep learning in real world, we use something called GPUs. They are dedicated AI, and what's happening? Cloud-based technology is making it cheap and easy. Okay, Google Cloud, Amazon, Microsoft Azure is making it cheap and easy, and that is why the companies are all trying these concepts today, guys. Okay, so that's a little bit of history. Let's see what else I have. So again, these are some of the frameworks. Python, some of these are deep learning frameworks. These frameworks are also free, especially in the world of Python. If you go to SAS and SPSS, they're commercial, they're expensive, and things like that, guys. Okay, so the algorithm is called as a black box. It's taking the input and then it is giving the output, guys. Okay, imagine you have a group of emails coming in. Some of them are spam, some of them are not spam. What do? That's where we can use machine learning. Okay. So in other words, here is another example. You have a house. If you have a house, the price of a house may depend on the size of the house, the number of bedrooms, the street, the area, the overall condition, and the year built. What are they? They are called the features. Okay, what is this? This is the language of machine learning. This is the terminology of the machine learning. If you go into the world of cricket, everybody is talking in terms of runs, wickets, bad ball, and things like that. This is the bad ball, runs, and wickets of the machine learning. They call them as features. Label is the price of the house. Okay, so similarly, to predict if a mail, if an email is a spam or not, what does a spam mail look like, guys? Okay, spam mails generally, the marketing mails, they'll say, hey, you won a lottery, please call me. It is urgent. Here is my landline. Urgent, urgent, urgent. Something like that they'll have. So what is that? That is a spam mail. What do you do? That can be detected based on these. These are called the features. Sender's address, hours of the day, spam words, number of capitalized words, and things like that, guys. Okay. Can I find one algorithm how it is in Python? Okay, Ram, if you looked at the students and marks predicted, buddy, that is called linear regression algorithm. I'm sorry, I did not go too much into detail. It is too early for us to go into those things if you don't have an idea, but I'll slowly take you there, buddy. But what we looked at earlier is an example of an algorithm, Ram. Bird-like device which transfer parcel from one place to another using deep learning. The bird-like devices are these things, right, guys? Today they're using deep learning for detecting, what are these things called, guys? The word is missing. Social distancing. The small things flying in there. What are they called? I'm missing that. I'm surprised. I'm missing that. They put these, small chips inside that, and these things, guys. Shoot, drones. Sorry, my bad. Samantha Saini. Thank you. Appreciate that. Sadak, thank you. Sorry about that, guys. The drones, they have these chips with deep learning software or computer vision combination. They're detecting this all different kinds of objects, and the social distancing is maintained or not, and things like that. Ram, if that is what you're asking, buddy. Okay. Garbage in is garbage out. To predict the price of a house, you can look at the size, you can look at the number of bedrooms, but don't look at the neighbor's home, neighbor's phone number. Don't look at the neighbor's name. If you're looking at the neighbor's name and you're predicting the price of house, then that is called as garbage. Okay, in other words, that is called feature selection. That is where what is one of the most complex things, guys. Okay, most complex is, it's not complex, but there's a lot of creativity which will come in the form of feature selection. Again, that is y is equal to f of x. That's like an equation. We get the equation from the data. That is what is machine learning, guys. So here is an image of a bird. At a mathematical level, it is nothing but a group of pixels. Pixel is, a different color, groups of colors in a different way. What are they? They become the features for binary data. Okay, the label, whether it is a bird, whether it is a cat or a dog or a cheetah, becomes the label. Okay, and what is x and y? X is the yellow or the orange is called the features. The y is called the label. The labels is again cat, dog, or cheetah, and things like that, guys. Okay, imagine this is Sarthak. Sarthak, imagine, is one day going for hiking on a mountain. And now imagine he wants to take a picture. He wants to use his mobile and he wants to take a few pictures of the birds. And he wants his mobile to detect or predict if that's a toucan or that's a special kind of a bird or what kind of birds and things like that. What can we do? That's where machine learning can come to your rescue. Ideally, what will we do? We will build a model. We will take a group of images of different kinds of birds and animals. We'll give it an algorithm. The algorithm will go ahead and give you a model. The model can be shipped out to all the mobile phones. If there's only one, we can send it to one guy, or we can, and this is what companies are doing today, guys. Okay, they send the snapshot that to the model, and now as you take a picture, that model is predicting whether that's a toucan or not. This is what is happening in real world, how things are working in a real world, guys. Okay, so this is called generalization. Generalization is being able to making the prediction correctly. Then we have a couple of concepts called underfitting and overfitting, guys. Okay, so for today I will not go into underfitting and overfitting. It is little too early to go into those things, but let's see. There is supervised learning one more time, and let's see if I can touch a little bit about supervised learning, guys. Okay. Okay, the most common use case of machine learning is supervised learning. It is learning under the supervision of a teacher. It sounds like as if there is a teacher and you're training. If there is a kid, imagine Sarthak is a kid. You're telling Sarthak, you open a book and we are telling him, hey, Sarthak, here is a cat, here is a dog, and things like that. He's a kid and you're training him. It's like we are teacher, Sarthak is a student, right, guys? So what is it? It sounds like as if you're supervising. And what is Sarthak doing? Sarthak is a kid who is forming a picture in his brain. The picture is the model at a neurological level. What are we doing? In a mathematical world, we are forming a mathematical model. We are exactly following the same process in a mathematical world, and that is what we call that as a model. Okay, so it sounds like we are supervising. That is what is called supervision. So here it is again. What is supervision? Show the image of a dog and say this is a dog. That is supervision. You take a group of images and say whether something is a dog or a not dog. That is the first step. That is called labeling. Then you clean the data set. If you take a look at this is not dog. This is something else. What do you have? You have not dog. And this is also, what did we have? No, this is also not a dog, but this is a dog. What is that? That is bad data. What did you? You clean that. If something is a dog, you have to say it's a dog so that the algorithm will understand, so that you're not confusing the kid. Okay, that is called cleaning. Then what do? You build the model. Neural networks. Okay. Okay, I'm coming there, Raj. Ram. So in supervised learning, there is something called classification and regression. Okay, what is classification? Imagine there's a cricket match tomorrow. Imagine Ram is a big fan of cricket. Imagine Ram wants to predict if India is going to win or not. Tomorrow we are playing with Australia. Australia is a tough game. Whether we're winning or not is yes or no, it's textual data. That is called classification. If you have two choices, we call that as classification, guys. Okay. If you want to predict, imagine Ram is a fan of Virat and he wants to predict if what score Virat is going to score. What is score? Score is a numeric data. What is that? That is called regression. Okay. So if you have two choices, we call that as binary classification. Spam and not spam, dog and not dog. If you have three of them, let's say yellow, green, red, blue, and things like that, that is called multi-class, multinomial classification is what it is called, guys. Okay. And that is classification. So there it is. Whether we have the heights of a few people, we have a weights of few people, and based on their height or weight, we already know whether somebody is male or female. Okay, so the blue color is the X and the green color is the Y. What are we doing? Imagine we plotted it we mathematically represented. So all the greens are, let's say, females, and all the blues are, let's say, males. Females are on the, girls are on the left hand side, boys are on the right hand side. What do we do? Well, at a mathematical level, we can draw a line. And anybody who's on the left hand side can be classified. We say we classify them as a girl, and anybody who's on the right hand side is classified as a boy. But we can also draw another line. What do? You don't draw a line. You have the algorithm draw a line. That is what the algorithm does. This is called support vector machines. What does the algorithm do? It will try to draw the line which is as far away as possible from both sides so that the errors will be minimal. That is called support vector machines, guys. Okay, what's happening? When a new point comes in, after it draws the line, the best line, what does it do? The point, if the orange falls on the right side, we're calling that as a boy. If it falls on the left side, we call that as a girl. That is how the support vector machines work. Because it's a boy or a girl is yes or no, that is called classification. Okay. So again, here is real estate agent. What do real estate agents do? They will predict the price of a market. What is that? That is numerical data. And the price of a house may depend on the size, the number of bedrooms and things like that. Those are called the features, guys. That is called regression. In other words, if what you're predicting is a numerical data, that is like price is numerical, age is numerical, weight is numerical, then that is called regression. It's like predicting Virat's score tomorrow. Okay, guys. It is a statistical method for estimating the strength of the relationship between a dependent and an independent variable. What is the price of a house depends on the number of bedrooms and the size. So price is dependent, price is called dependent variable. Number of bedrooms, the size are called the independent variables, guys. Okay. And here is an example of an algorithm, linear regression, slightly at a high level. There is a group of points here, green points. And what do we have? These are the independent variables. Generally, dependent variable is represented on the y-axis. Independent variables are represented on x-axis. What do you use these? These are called data points. What do? We draw a line. Not you, but the algorithm. The algorithm draws a line which is as close as possible to all the points. That is what we learn part of the machine learning in the coming updates, guys. Okay. Internally, it uses a function. It is called a cost function. It is a function which is trying to figure out which is the line. There can be many lines you can draw here, but which is the line which is the closest to all these points? Well, that is what this function does. It calculates the error. It draws the line, guys. Okay. So classification and regression. This is nothing but when you're predicting textual data. This is nothing but when you're predicting what is called numerical data. It is called regression, guys. Okay. Supervised learning, again, you supervise it, is what that really means. I'll skip that. Unsupervised learning. Now, here is another deep one. It is called unsupervised. We have in unsupervised learning, we have something called clustering and dimensionality reduction, guys. Okay. What is clustering? It is a task of identifying similar instances with shared attributes in a data set and group them together. In other words, we don't have labels here. Okay, so imagine you have a group of points. What are you doing? You're separating all the groups of points. All the reds represent something, all the greens represent something, and all the blues represent something. They can be anything. They are called the clusters. This is called clustering, guys. Okay, so here is customer segmentation. These are all the group of customers. Red customers are the customers who are risky. They may, if you give loans to them, they might default. Here are the greens are the ones who will not default. Blues are the ones there is a 50% chance of them for them defaulting. That is also how you can think of. But again, we will actually do this customer segmentation, anomaly detection, and semi-supervised learning. This is also called semi-supervised learning in a way. These are some of the things that we will do, guys. Okay, what is anomaly detection? Take a look at the red color fish. Among all the blues, among all the sizes, its size is bigger, and it is also in red color, guys. Talk to the instructor post this class. Okay, yeah, you can. You want me to unmute you, Preeti, now? You can just pause this class. Okay, no problem. Take your time. Okay, so anomaly means something which is odd. Imagine we're all making, we have taken the salary of everybody. Let us say Ram is at 50,000 rupees, Manish is at 1 lakh rupees. All of us are between 50,000 rupees and 1 lakh rupees. But here comes Preeti, she's making $1 million. What is special about it? She's too far away. She's too different from everybody. What is it? That's called an anomaly. That is where the clustering techniques can also come to our rescue. Okay. Then comes the dimensionality reduction. This is also called unsupervised learning, guys. Okay. So what happens is one big challenge to handle is the number of features. So here is an image. It is 1000 by 1000 pixels, which means in 3 dimensions. An image is a group of red, green, and blue. So you take 3, multiply 1000 by 1000, you get 3 million dimensions, which is nothing but 3 million pixels. It's like 3 million features. That is ridiculously very, very huge number of features. What do? In many cases, all of them are not needed. If you want to identify that image as a cat or a dog, you may not need 3 million. Why? That needs a lot of processing. What do? That's where we reduce the dimensions. You try to understand, you try to figure out which are the most important features. How? Use an algorithm. Bring in the machines. Machines will do that. You don't do it, guys. Okay. So imagine a cylinder that is in a 3-dimension. But take a look at this. What is it? In a 2-dimensional, it is nothing but a circle and a square or rectangle. What is that? That is what is called dimensionality reduction. If you understand it in a slightly simple way, don't work. Where you need a hammer, don't use a screwdriver. If you can do something in a simple way, don't use a complex way. That's what is the objective of dimensionality reduction, guys. Okay. In real world, we can use these techniques to identify. So if you take a look at this image, all the humans are in red color, all the vehicles are in the blue colors. This is called clustering an image. All the trees and plants are in green colors, buildings are in a slightly grayish color. These are the techniques that we can use the clustering for, guys. Okay. Then we have reinforcement learning, but okay, let me complete this. It is learning from the interaction. It is also called feedback from the car. Okay, so playing computer games, handling dynamic environments are very, very complex things. Sending robots to NASA or Mars. What is it? Do any of you recall this name of this thing is? There was a, what is that? I don't seem to recall. But these are the things where we can use deep learning techniques. ATV, there's some name, buddy. It became very popular. It landed on rover, I think, right? Mars rover or something like that. It landed and it uses deep learning techniques to identify where to, to make decisions. That is called reinforcement learning, guys. Okay. So if you're playing a chess, that is a very highly Mars rover. There you go. That's a very highly complex environment. It needs a lot of feedback, much more feedback. This is where traditional machine learning algorithms fail. In other words, they will not fail, but they'll give you less accuracy, less success. That is where it's a very dynamic environment. That's where reinforcement learning comes in. What is that? It is like a feedback environment. Humans, on a daily basis, we take a lot of feedback from our environment. As humans, we get feedback from our parents. If you're married, you'll get it from your wife or husband. You'll get it, sometimes we get it from children, sometimes we get it from our boss and things like that, right? So what is that? Everything else is environment. Okay, what do? Imagine you're a person, you went to gym. There's a 20 kgs, what is that called? That weight. Okay, now what did you do? You picked it up and you suddenly realize that's too heavy. So what do? You now put it down, you pick up a 10 weight, and what do? That's too light. So what do? You pick up a 15. And what is it? That is also okay. So what do? You go between 15. What are you doing? Based on the environment. Your gym is your environment based on the different things that are happening there. What you're doing is you're trying to move to an optimal point. What is that? That is called feedback. It's called feedback based learning or feedback learning. It's called reinforcement learning. That is what is deep learning. Okay, deep learning internally uses neural networks. I think Ram or somebody were asking what are neural networks. They internally use what is called neural networks, guys. Okay, learning from the interaction is a foundational idea in our life. Remember, learning is life, guys. Okay, so let's see. I'll cover a little bit of theory and move on to a small project here. So here is Tom. Tom wants to sell his car. How much money should he sell his car for? Quantile robust is important or no? I mean, you can use quantiles, but there are many other nonlinear algorithms more sophisticated, which we can use, Rajshri, and we can use. It's not that we test, generally we test multiple algorithms. Okay. How we know which algorithm we used in our model? If you have a hammer and a screwdriver, how do you know? Well, you learn. If you want to fix a nail into the wall, use a hammer. If you want to fix a nail into the door, use a screwdriver. Don't use a hammer if you need a screwdriver. What do? You learn. That is what we learn as part of the course, Manish. Okay, buddy? Okay, back to Tom. He wants to sell his car. How much money should he sell his car for? Okay, the price he said should not be too high, but it should not be too low either. Okay, what should we do? Our objective is we should estimate the car price. How can we help Tom determine the price for his car? Is there data on the prices of the other cars and their characteristics? If you want to help Tom sell his car, what we are doing is we're trying to understand, do we have the data of other cars? If the data is there, what do we have? Do we have the color of the cars? Do we have the brand? Do we have the horsepower? Do we have more? What is this? We are asking the questions. Why? To decide, to help Tom sell his car, guys. Explain the layers of technology used. Machine learning and data science work together. Oh, chatbot. Okay, Divya, chatbots we'll see later. I think in today's, for today, I may not be able to go that far. But Preeti, yeah, you'll be understanding those things, Preeti. What you're asking is a good question, but it requires a little bit of more depth than I can explain in the scope of this one, is what I would say. Okay, but that's a good question. So okay, so the first thing is to help Tom. Why should we do data? analysis. Why? Because data is everywhere. It helps us answer the question. We don't want to sell it too high. We don't want it to sell it too low. If it's a good car, you give it too low, you're losing. If you're selling it too high, nobody will come to you. So we need to do the right price. In other words, we need to make the right decision. That's why we're using data analysis. That's what companies want. They want to make the right decisions based on the data, guys. Okay. Data analysis plays an important role. Discovering useful. What is useful? You say you sell it for the right price. That is useful. You answer the questions, you predict the future. That is also useful for the clients, guys. Okay. So here is the data, roughly how the data looks like. The first thing is we understand the data. That's our data. It's automobile data. These are the features. We have the symboling. We have normalized losses, make, fuel type, whether it's gas, petrol, and things like that. So these are all called independent variables. And here is the target. When we have data like this, what we want to do is we want to help Tom in predicting the price of a car. So price is our target. That's called dependent variable. Rest of them are called independent variables, guys. Okay. What do? These are some of the packages. Pandas, numpys, scipy, used for manipulating the data. These are some of the package for visualization. These are some of the packages, the Shah Rukh Khan and the Salman Khan of machine learning in Python. Scikit-learn is the Shah Rukh Khan, the most popular language machine learning library or the package of the world. Then comes the stats models. Together, they are generally used, guys. Okay. Repeat them slowly. Oh, sorry about that. Okay, sorry about that, Preeti. Okay, I'll go a little bit slow. So the first step we do is import the data. We can have the data in the form of Excel, CSV, or in other formats. What do? Read CSV. That is your function. That will create a data frame. That's what we have seen. Then we start looking at the head. We start looking at the tail. They give you the first 5 rows and the last 5 rows. And here is, notice the headers. Roll 1, 2, 3s. What did we do? We said header equals to none here. That's why we don't get a header. But we can say columns equal to headers like that. If you give the column names, you'll get the right column names there. This is part of the data pre-processing, guys. Okay. You can also save the data frame to a file. What is a data frame? Again, I will not go into that details. I will save that for the coming up days, guys. Here I'm trying to give you a big picture. So again, these are the different files to which we can save. What are they? They are the functions. They are the methods which are already available. What you do is you don't by heart. You just be aware of them. That is what is Python. Python gives you a lot of tools. There's a hammer, there's a screwdriver, there's a wrench, there's a nail cutter also. What do? Know when to use which tool. You don't have to write them. That is what is the advantage of Python. Pre-processing, the process of converting or mapping data from the initial raw form into another format in order to prepare the data for further analysis. That's a formal definition. Okay, you don't need to by heart it. But some of the things we do, identify and handle missing values, format it, normalize it, bin it, and things like that. What are SAV? SAV is the SPSS files ROM. SPSS saves its data in the form of SAV files. This file can also be saved as SAV if you save it in SPSS, as simple as that. Cool, buddy? So that's the data. What is it? You can select the rows, you can select the columns, you can manipulate the columns, and you can fix the missing values. So take a look at this. There is one car, the normalized loss. I don't know what is the meaning of it, but it is missing. What do? You can fix it. You can drop the variable, you replace it with a mean, average, or with other kinds of things. This is called data pre-processing, guys. Okay. So notice 22, the price is missing. What can you do? You can drop it. You can remove that row, or you can replace it with a mean. That is what we do. Again, here is replacing. Earlier we dropped. This is drop. Drop any, as the name says, it drops a row. This will fill. This is replace. Replacing NA means null value. Null value is being replaced with the average value. Okay, then you have the formatting. So notice NY New York. Some people say N.Y. and so on. These are all different formats. You try to bring it to a standard format. This is called formatting. Then you apply calculation. This is in miles per gallon. You convert it to kilometers. Okay, kilometers. Or this is in miles, this is in kilometers. That is, you're doing a small calculation that is called applying calculations. Okay, Then that is the price. This is the price incorrect data type. So here, this is indicating it's an object. These are all numerical data. Object means it is treating it as a textual data. What do? You convert. You have objects, you have ints, you have floats. You convert it into what is called numerical data. This is how you convert. Okay. Then you normalize the data. So take a look at the length, width, and height. Length is going from 150 to 250. Width is going from 50 to 100. Height is going from 50 to 100. They're all in different minimums and maximums. You can bring them to the same scale, which is bringing it to a scale of 0 to 1. Okay, that is called normalization, guys. Okay, and there are different techniques. These are the different techniques for normalization. So this is, one technique, and here is with pandas, this is the standardization. This is the standardization, mean by standard deviation and things like that, guys. Okay, then you have binning. Binning is, you have this data, you're bringing it to low, median, and high. That is called binning. Then that is called the visualization, guys. Okay, then last one is turning categorical data. A car is gas versus fuel. It is not necessarily a car which is gas. Gas is petrol, will give you more mileage. Sometimes there are few cars which are diesel, they give you more mileage. And what is the problem? This is all textual data. And if you have textual data, machine learning algorithms will not work. They will work with only numerical data. What do? That is where you take textual data, you convert it into numerical data. So wherever there's a diesel, you're putting a 1. Wherever there's a gas, you're putting a 1. This is called converting textual data to numerical data. This is called one-hot encoding, a slightly fancy term, fashion in the world of Python, guys. Label one-hot encoding, right? So those are the dummy, they're also called dummy variables is what it is. And this is the process, guys. Okay, so descriptive statistics, let's see. As simple as that, let me come back here. So in other words, these are some of the steps and things like that that we generally do, guys. Okay, so enough of theory. Negative values with flat minus can have. Tough question. Ram is asking, what if it's a negative value? You can discuss with your business. Simple answer. Imagine you're selling a car. Let's say the petrol is petrol or whatever, the miles per gallon is negative. You go and ask, hey, what should I do with the negative value? Maybe they'll say, hey, that's a mistake. Negative means, your miles per gallon, your mileage is not in negative. It's probably positive. And 0.1 is like almost nothing. If something is giving 0.1, that's a very, very small thing. So maybe we should remove it. Don't even consider that car. Why sell that car if it's not giving any mileage? Things like that. Those are the discussions which will happen, Ram. Okay, buddy. Cool. Okay, Ram, hope you're okay with that. Okay, let's see what we have, guys. Okay, so let me come back here. Now we'll take a look at another project which you might find it useful in your real world. Here's a Glassdoor job search. Almost on a daily basis, we all wake up and we are thinking of jobs, joining, getting a good one, trying to find the right one and things like that, guys. Okay, so imagine Glassdoor. Glassdoor is one of the popular job search engines. And what we will do is, our objective is, we will try to look for some jobs. We don't have any data. This is a scenario where we don't have any data. Many times companies don't have any data. What they will do is they will ask you, hey, there are some websites. Can you get the data from there? What do we do? This is what we do. This is called data collection step, guys. Okay. So let me come back here. Let's see if I have that here. Back here. One more time. Oops. There you go. This is free workshop. True. Tassim, Fatima. This free. You can also attend from tomorrow for a few days, Tasima. This is one of the projects that we'll be doing towards the end of our course, guys. A slightly advanced project. In California, electricity grid operators, footprint, CAISO, we need to predict what is the daily ahead market price, hourly ahead market prices for wholesale electricity. using system operated demand forecasts, weather observations, and reservoir water levels. In other words, what this is telling us, we need to predict the hourly prices and the daily prices of the electricity based on the forecast demand, based on the demand for the electricity, based on the weather, based on the reservoir, water reservoirs at different places. Okay, then we have different kinds of data. There are 16 weather features, one water level feature, 4 date and time features, and an electricity demand feature. It's one of the most complex projects that we'll be doing. This is almost coming at the end, but I'm just giving you an idea, guys. Okay, so these are the some of the variables information: daily ahead price, 7-day load, 2-day load, temperature, wind, visibility. You can give a thought why the price of an electricity depends on temperature. Why does it depend on the wind? Why does it depend on the visibility? Why does it depend on the ceiling? Ceiling means cloud ceiling height. Okay, so these are things we'll be reviewing, and here is a process. The first step here is, this is also a project where we don't have any data. Okay, in other words, an electricity company has asked you to come in and they're telling you, hey guys, we want to predict the price of the electricity. What do they tell? They tell you don't have any data. So what is the first stage? The first stage is data acquisition. You go to a website, they will show you the website where there is electricity data. You try to get the data. Then we try to create the data frames. This is the pre-processing. You try to merge it. Again, do a little bit of more pre-processing, which is the techniques that we just discussed. Then exploratory data analysis is where we are visualizing. Then we model. We using the traditional modeling techniques, then we use the deep learning techniques, and then we do the prediction. Okay, so there are slightly reddish colors is the data acquisition stage. The slightly blue and slightly orange is the data creation and the merging. And I think even so, data acquisition, this is the data frame creation. So the next two are the data preparation. Then here comes the visualizations. This is the dark red, or maybe close to maroon, is the EDA, visualization. And the last one is the model building. This is the traditional modeling, and this is the neural network modeling. Then the last one is the deployment. Okay, so today we'll see a slightly similar process which is applicable at an individual level, guys. Okay, a lot of companies do this kind of techniques on a daily basis, and let's apply it at an individual level. So here is get jobs, a function. I will not explain a word by word. This is a slightly advanced one, but take a look at this. Let's scroll down here. Here is get jobs. If I run this one, notice what this will do is, this is connecting to this website. Let's scroll up here. Here we go, glassdoor.com. Let's say, copy this, come here. Here's this, let's run it. Give it a moment here. So take a look at this. Being redirected, undo, okay. So let's scroll down. Comes up with this one. Redefining all job types. So principal, firmware engineer, QA engineer, PPC analyst, software engineer test, Amazon, Micron. Scroll down here, notice contract administrator. These are all the different kinds of jobs. And then it has, go to the second page. So 30, 30, 30. So what is this? This is the URL. What is this? This is the URL of a internet website page. Here is search, click source, type the keyword. Type the keyword is whatever we type. We did not type anything, or in other words, more precisely, let me come back here. I have to initialize the keyword here. More precisely, that's not what I give. The keyword here is, scroll down here. Data scientist. So let's copy this keyword. Let's put data scientist. Cool. Now let's run. Okay. Principal firmware, PPC analyst, QA engineer, software engineer. Keyword is data scientist. And let's see what else I have. Here I'm getting only 5 of them and I'm putting a 0. So there's the keyword, location, suggest com, location, country redirect equals to true. Okay. Or in other words, let's say, let's put data scientist here. I wonder why it didn't take that. Let me run this one, guys. It should have only showed me data scientist jobs. So there it is. Now we are getting it. Earlier I had keyword there. And actually, I think I need to go into advanced search and I need to do that. But notice data scientist, scroll down, data scientist, data analyst, Python programming, valuation at risk. These are all the data scientist related jobs. What is it? If you scroll down, there are a lot of them. If you click them like that, if you want 1000 of them, you have to click 30 times minimum. 30 times 30, that is 900. So what we'll do is we'll now click, we have written a small function called get jobs. If I run this one, notice, I'll run this one for sake of showing you. Here, I'm only getting 5 of them. Let's give it a moment. Quotes, I think, was there, isn't it, Akash? I thought the quotes were there, but my thing is running very slow today. So notice it is running. Let's give it a moment. And this is getting in US only. This is the first file that we have seen when we got here. If I run 1000, so the 5 jobs will run now, it'll take about 1 minute to 5 minutes, guys, okay? So just to make our time a little bit productive, first time I'm joining. Okay, Fatima, just, look at the previous workshop that, previous webinar video, and then try joining in from tomorrow. I'll be starting from basics, Fatima. 8 to 9, roughly 8 to 9, 9:15 like that. Just try to join from tomorrow and I'll help you catch up and things like that. Okay, Fatima. Okay, there you go. So there it is. It's now started working. It's getting the first one. Then it'll take about a minute or 2 by the time it completes, guys. So while that is running, let's get one more. So that is the first one. It is scanning it. So there it is getting the second. Let's give it a moment. And while it is running, earlier, sometime back, yesterday or day before yesterday, these are 1000 jobs that I have already downloaded. It took an hour or 2 hours for me to download all this stuff. Notice 957 rows roughly. I asked it, I tried to get 1000. The only change I did was instead of 5, I've given 1000 there. I've already saved into a file called Glassdoor jobs. So these are all the job titles, salary estimates, what we looked at in the beginning, and so on. There's a sector, revenue, company name. Let's see what's here. Industry, company, that's it. That's our data, guys. So about 1000 jobs I have already. Is math very important? Required math. There is some math you need to have an idea more. That is the statistics and the linear algebra part of it. That's what we'll be going over. That's what I will help you catch up and understand. Okay, buddy. Cool. Okay. So there it is. 5 are done. That is for the sake of, just showing it to you. Oh, that's what that get jobs is automatically doing. It's browsing one after one, it's automatically detecting that, buddy. Cool. Okay. So once you get it, it's called a data frame object. And if you scroll down, these are the jobs. Earlier, I downloaded a day or 2 days back. Job title, salary, company, and so on. Now, take a look at this. So since I saved it to this file, because it will take a long time, if I run this one, here is the top 5. Top 5 jobs. And now take a look at this. The tail will give you the last 5 jobs. Generally, this is the process we follow. Start with looking at the top 5. Then look at the last 5 just to get a feel of it. And scroll down here. Shape is telling, hey, there are 956 rows and 15 columns. You look at info and take a look at all of them are 956, which means all of them, they don't have any missing. Imagine this had something like 950. That means there are 6 rows, 6 values which are not there in that particular column, is what is the meaning of that. What is false? Boolean. Oh, that's just telling a data type, buddy. Where are you seeing that? Okay. That's just telling you data type, buddy. False is again true and false. Boolean is true and false. That's a data type, just like numerical data and textual data. So now come back to salary estimates. Take a look at salary estimates. If we come here, just for the sake of simplicity, let's come here. Take a look at this one. You do a filter, data filter. Click on salary estimate. If you look at this slightly, there are some jobs $10 to $17 per hour. Some of them 100K to 160K. Another one 100K to 166K. These are all, what are they? They are unique. Some are employer provided 100K to 135K. So these are all the US jobs, guys. I purposefully took the US jobs. Later in our course, we'll analyze the Indian jobs, okay? So 94K to 153K and so on. So let's say that is the salary estimate column, which is the second unique. That's what that is giving you. Scroll down here. Oops. Oh, this one. These are all the unique values. Now, next comes in data cleaning. So if you look at salary estimate, if you want to know how many of them have 86K to 143, it looks like 6 jobs have 86,000 to 143,000. Then there are 6 jobs which have $21 to $34 per hour. So some of them are per year, some of them are per hour. Then you have salary estimate equals to -1. In other words, one more time, for sake of simplicity, if you filter this one, notice there are some which are, let's say, these are -1. If I select only this, salary estimate is -1 means what is that? That is bad data. It is not giving you an idea of what is the salary. What is salary? You're saying you want a data scientist and you're saying salary is -1. What is that? That's bad data. So what do you do when you have data which is not really meaningful? You try to fix it. You try to clean it. That is called cleaning. Okay, so let's come here. So what do? There are totally, let me scroll up here one more time. Let me run this one. Why it's taking so much time, man? Spider is closed. Okay, that is run. So that is the head. So let me run tail. Give it a moment. Okay, that's tail. Then run tail. So right now we have 956 rows and 15 columns. What is this? This is the data we got from internet, guys. There is the info again, I'm running it. This is unique. Sorry guys, I have too many applications open here, so that's why it's running a little bit slow, but generally it is pretty quick, guys, okay? So now here is value counts, run it. And now here, what I'm trying to do is, how many of them have head equals to -1? This is a Python way of doing it. In Excel, we filtered it, but in Python, it is much more than what we can do in Excel. In other words, Excel is very manual, guys. Tomorrow, which time class? And say 8 to 9. The next week I'll be taking 8 to 9, then slowly I'll be taking from 8 to 9:15, Fatima. So 1 hour to 1.5, 1 hour 15 minutes maybe, approximately. Be prepared. Okay, so now let's say one more time, I'm looking at the shape. Shape is giving you right from data extract. Good idea of explanation. Oh, thank you, Rajesh. I appreciate that, buddy. Thank you. So right now we have 956 rows, 15 columns. So now what we are doing is just separate the salary estimate column into something called salary. Link will be shared for tomorrow's joining class. Yes, Divya, they will send you the link. Please type in, those who are interested, please type in your emails, guys, just so that, you know, we also have a track in the chat window. Just type in your email. Sorry about that. Okay, so now come back here. Take a look at this. What we are doing is, in salary estimate, there is one problem. What is the problem? Salary estimate should tell you what is the salary, but notice it has $53K. That is okay. But what is this glass door? You know, every job has this one. So that is not really not a necessity. Okay, so come down here. Up to 9, Fatima. So what we are going to do is we're going to split it. I will say, okay, just to save our time, what I'll do is I will not run it because I have already ran this. If I do this and do a salary, notice what is happening is the split is splitting, separating. It splits, it separates this part of it and is removing this part of it. So when you say 0, it is separating and giving you that part. Okay, so that becomes the salary now. Salary has only this part. So in other words, we are cleaning it. We're removing the unnecessary part of it, guys. Okay, next come here, minus KD. So here what we are doing is we also have this K. We can remove it, days for dollar. So what we are going to do is we are going to replace K with an empty string and dollar with an empty string. So now we change it to that format. From this format, it changed to this format. Again, that is data cleaning. Next, if you take a specific one, 161, they're saying a particular salary is employee provided and they're giving you something like 120 to 145. Similarly, these are also a few values which have something like that. Employee provided salary, 200 to 250. Okay, so what we are doing here is per hour. So salary estimate. In other words, what that means is there are some jobs here. If you come back here, let's do a filter. Let's say select all. Notice some of them are full salary, whereas some of them are per hour. So what we want to do is we want to separate all those things which are per hour. We imagine we only will be taking salary, not the per hour things. Okay, so what are we going to do? That's what we're going to do. If per hour is there in our salary estimate, okay, what is it? Then what we're doing is we're adding a column. We're adding a column called, this is how we add a column, guys, hourly. So right now in the original data, if you scroll down here, notice company is the last one. Company, come here, click on, oops, one more time, click here, move here. There it is, competitors, sorry. Competitors is last one, there is no hourly. So what we are doing now is we are adding a column called hourly. In that one, what we are doing is we are putting a 1 or a 0. So scroll down here. So notice now, if you say head of 2, it will give you the top 2 rows. We have added a column called hourly. This hourly 00 means it does not have per hour. If there is a per hour, then it will be. The data will be in tuple or list. Okay. Both of them are iterators, buddy. Short answer. Ram. Okay. Similarly, another one is salary estimate is employer provided. So in other words, we are adding another column called employer provided. So notice here, the last column is hourly. Then what we are doing is we are adding another column called employee provided just to track. Here, after hourly, we are adding employer provided, which means if in the salary estimate there is employer provided, if that string is there, if that text is there, then this will have a 1. 0 means it is not employer provided. Okay, notice salary is 53K to 91K. So we're adding another column. This is called data transformation. These are the kind of things that we do. Next, replace per hour. So wherever there is a per hour, replace with empty string. Okay, I think we have already done it. Minimum hour. Then what we are doing is we are replacing employer provided also. So what is this? Notice 53K to 91K glass door. So what we are doing is we are replacing per hour. If there is per hour, we're replacing it, and we're kind of changing it, bringing it into that format. Then what we are doing is, so that is minus KD. Now we are adding what is called minimum salary. In here, what we are doing is minimum hour. Minimum hour is, we are going into this one. This is minimum hour. What you do is you extract whatever is on the left hand side. After you split with a hyphen, extract the left hand side part of it. And what is that? You add a column called minimum salary. So now notice you added minimum salary for everything. This is the minimum salary. Let me just move this here, move this here. 53 and so on. Similarly, we can add the maximum salary and the average salary. So that's the next one we're doing here. There is a maximum salary. So minimum, maximum, and average. And the variables which we are creating are provided are the targets which you're trying to find here. No, target is only one shade. That's a good question. The target is we're going to predict the salary, estimated salary later towards the end. What we are doing is we are creating new variables which are not there. This is called feature engineering based on the minimum, maximum, and the average. Catching it, buddy? That's a slightly advanced question. So I will not confuse others here, but good question. So here is company name head. So here is the first one, Ticolot, University of Maryland Medical System, Nobi, PNN, Affinity Solutions. These are some companies there. Now you say unique, it will give you all the unique names. Takeda, First Tech, and so on. Then you have value count. So Reynolds American is a company which posted 14 jobs. Mass Mutual is a 14 jobs. So software engineering, 11 jobs. These are the companies which posted only one. They're appearing only one time in company name. That is what is the meaning. What are we doing? We're getting a picture of the data, guys. Okay, that's what we are doing here. Then we're adding another column called company text. What we are doing is we are taking the rating. So in other words, more precisely, this is how the company name is. Reynolds America. What is this 3.1? We don't know. What is the 3? That is probably the rating of that company. The higher the rating, the better the company is. People are giving high rating is what it is. So in company underscore text, what we are doing is you're splitting that one. Okay. And then separating it. In other words, what this is doing is transforming that into something like this. Oh, sorry. Here, company text. Ticolot research. How was it? It was like this. Ticolot. Here we go. Ticolot research 3.8. We now transformed it into Ticolot research. In other words, we removed the rating. The backslash n is still there. That's called a lambda function. True. How do they work? Okay. Again, those are things I cannot explain now, buddy. You have to give me some time. It'll take a long time, but cool. Then comes the location. Location is the states, the Albuquerque, Linthicum, Maryland, and so on. Okay, now what we are doing is we are creating a new column called job state, and what we are doing is we are extracting the state. State is, this will be the first part, this will be the second part, and share this demo for repeating. Yeah, it'll be shared, Rajesh. That will be done at the end. So now this is the job state. Job state is a new column. Okay, these are the unique values, guys. All right. Then scroll down. What we're doing is, okay, New York, it looks like they posted 55 jobs out of the last 1,000 jobs that we extracted. 55 are from New York, 49 are from San Francisco, 47 from Cambridge. Okay, these are all the data scientist jobs, guys. Okay, next comes headquarters. There is something called headquarter for each company. There is also a column called headquarter. Baltimore, clear water. And now take a look at this. There is a column called location. So here is a column called location. Scroll down here. If you move a little bit towards right hand side, there is also called headquarter. So for this job, no B, the location and the headquarters are the same. There are some jobs where the location and the headquarters are same. There are some jobs where they are not same. So what do? Let's scroll down a little bit. That's what we are doing. Same state. We're adding a column called same state where if the job and the headquarters are in the same state or not. So if you look at head, same state, or more precisely, I will not touch that now because I did not run the above one. So here I just added a column called state. Then these are the years in which they have founded. This is another way of accessing the column. What do we? Some of them have -1. If you say a company started in 2010, and what is it? There are 32 companies which started in 2010, that is meaningful. We can understand. But what is the meaning of -1? That is meaningless. In other words, that is bad data. Cool. So here is some companies. What we are doing is, if X is less than -1, which means if that is -1, or in other words, more precisely, if it is less than 1. So if it is -1, what will happen is we are going to take X. Okay. If it is less than 1, we take X. Otherwise, 20 minus X. What that is doing is, it is creating a new column called H. If it is 2010, what will happen is 2020 minus 2010 will become 10. That will put a 10. That means how many years that, how old is that company, is what is the meaning of that, guys, okay? That's what we're adding another column. Then comes Python. In job description, how many columns have Python is what this does. So this will get all the jobs which have Python. If you look at that, it looks like 392 is 1, means out of this, we had originally 900. I think 300 we removed them. Close to 200 or 200 we removed them when we did some filtering. Okay, so remaining is 400, 750. Out of 750, close to 400 jobs have Python. That is, more than 50% of the jobs are asking for Python. Less than 50% of the jobs are not asking for Python. Okay, then comes R. We're creating, more precisely, a column called R. What are we doing here? We're looking for something called R Studio. What's happening? It looks like only 2 of them are asking for R. 1 means present, R is present, 0 means no. Then let's take a look at Spark. 167 companies are asking for Spark. Then AWS, 176 companies are asking for AWS. Spark and AWS are same. Then comes SPSS, only 16. Then come to SAPS, only 87. Like that, we can keep on adding more and more. What are these? These will become our features, guys. Okay. So these are all the columns. So the ones at the last are the ones we added. You can add whatever you're interested in. We can build a whole new application to be more precise. So what is this? This is salary data clean.csv. So if you come here, let's say file, say open, say browse, our data sets, let's say date modified, type in S, say all files, scroll up here, salary data clean, let's say open that. So take a look at this. So there is a job title, salary estimate, everything is there. These are all the original columns, but let's move towards right hand side. So there it is. These are the columns we started adding. Competitor was the last column. After that, we added hourly. Then we added employer ID. Then we added minimum salary, maximum salary, average salary. Then here is the company text. Company text is only University of Maryland here. Hope I didn't delete anything. Okay, then job, which state it is, whether it is in same state, the age of the company. Sometimes, some people, they're very picky. They only want to apply to companies which are 10 years old. They don't want to join the new startups. Why? The way they deal is very different. They don't have process and things like that. Then these are, wherever there's a one, that means this job description is a Python. This does not have R. This does not have Spark, does not have AWS. This has SAS, Python and SAS. If you remember, more than 50 or 60% of the jobs have Python. Everybody with me so far, guys? Can you give me a quick yes, please? Are you getting a slightly high-level idea of what I'm doing? I don't expect you to be perfect, but that's a slightly high-level idea. These are things that you could do on a daily basis. You can run them. And you can do lots of analysis, guys, okay? And this is what the companies are doing. They write scripts like this, they run them continuously on a daily basis, they download the data. This is called data acquisition. Then we are cleaning the data. Now here is, again, one more time. Just for sake of discipline, we have loaded this one. And now we are saying title simplifier. This is a function. You can do it on Mercury, you can do it on Monster. You can start selling the data to other people who might be interested, other companies. You can help the other companies also. You can do it for cars, you can do it for Amazon. Gentlemen, ladies, that might look like what I'm showing you, might look like something you're thinking only from a jobs, but you can use that concept globally. This is what companies are doing, guys. Companies are downloading. When we say we can get the data, if you recall, earlier I have said we can get the data of Preeti, that she loves to travel, she's into fashion, she's into sports, health, and things like that. What is that? This is what that is. We can download the data of different people, different customers, and analyze this in this format. Okay, but stick with me. Rajesh, are you getting the idea, buddy? The concept is same. You can use it in multiple things, is what I mean. Cool. So, okay. Take a look at this. Data scientist in title, then written a data scientist. So there are different kinds of titles. So if anything is a data engineer, analyst, and things like that, what we are doing is we're giving a slight, just a different name for it. So here is seniority, and here is job title. Data scientist, it looks like there are 131 jobs. Then there is data engineer. So even in data engineer jobs, they are putting a data scientist. In senior data scientist, data analyst, senior data engineer, these are all the different titles, but they also have data scientist in this thing. If data is in Oracle, yes. As long as your data is available on the web, buddy, you can scrape it and get it. That's what we'll be doing. That's what we'll be learning. Data scientist and data analysis. Data analyst will not do predictive modeling. They will only do the pre-processing part of it. Data scientist also does the predictive modeling. Predictive modeling is the batting. It's the heart of a data scientist. Data engineer will also, most of the time, they will do pre-processing only. Okay. And more precisely, that's data engineer is more of a big data engineer. They are the guys who are familiar with Spark and Hadoop. We'll also be touching and learning them, guys. Okay. So that's again real quick, buddy. But back here, so what we are doing is, notice data scientist, which was like that. What did we do? We converted it to lowercase. Why? If there is a data scientist, which is, let's say, in capitals and in lower, both of them are same. So by converting it to lowercase, what will happen is we are not thinking they're two different jobs, they're one job only. So now notice it's coming to be 279. Why? It probably took the capital D capital as one different and small d capital S as one different. Web scraping is data mining. It's part of data mining. It's more of data acquisition, but data mining is machine learning. Catching it? So that is simplified job title is what it is. And now we know, hey, there are 300 jobs. That's close to 50% of the jobs are have data scientists in them. Not data scientists, but they're just data scientists. Rest of them also have data scientists in them. Next comes seniority. So then we're saying apply seniority. So based on senior, junior. So it looks like not available means these are all probably mid-levels and freshers. Senior is senior, juniors is junior. Most of them are mid-levels and probably freshers is what it is. Cool. Then these are the states. Each state, how many? Okay. So you can think from an Indian perspective also. You might be interested. You might be coming from, maybe a lot of guys come from Maharashtra, a lot of guys come from Uttar Pradesh and things like that. So if you're coming from there, you might be interested, hey, in Maharashtra, how many are there? In Uttar Pradesh, how many are there? You'd like to be maybe more in your own state and things like that many times, guys. Okay, that will give us an idea. Then the job description. So notice this is, we are taking each job description, we are calculating how much it is. Is there any correlation? Does job description have any connection with, with a job in any way, is what it is. Then competitors, some of them are -1, some of them have 460. So in other words, these are probably competing with the rest of the companies. So we can understand, it looks like Novartis is having 14 competitors, is what it is. So sometimes it will give you an idea who's competing more and things like that. So number of competitors, what we are doing here is splitting it. If it is not equal to -1, then let me see what I'm doing here. L0, putting a 0 or a -1. Okay. That I'm trying to recall what we are doing. Then we are calculating the minimum salary and the maximum salary they are offering. So we're adding something called minimum salary and maximum salary, and taking the minimum salary multiplied with 2 is what we are doing. So come here, there it is. Number of competitors, or here it is, because it's not showing it. Here is hourly, here is minimum salary. So hourly, minimum salary, and maximum salary. Oh, we are separating it, guys. Sorry. We have minimum and maximum together at one place. So we are separating it. What is the condition of job in India for data scientist? Okay, it is okay. So data scientist, again, these are things I have briefly discussed earlier, Ritu. Definitely, I will not say I'm promising you a job. Some virtual internships I can definitely give you. For some of you who are freshers and things like that, I generally give virtual internships. And at the end of the course, okay, because of the COVID and things like that, otherwise we used to ask them to come to our company. But jobs and things like that, what I will say is, you be ready. Because of the COVID right now, the condition is a little bit slow. It is not fair for anybody to open up right now. But when they open up, when the things will settle down, if you have R, if you have Python, you have machine learning, you have deep learning, you have computer vision, the value of your resume will be very high. Whether you're getting a job or not, you have these skills on your resume is my recommendation. You have them and you try, you will definitely have a lot more advantage. Fair enough, Ritu? Cool. Okay. Hope you're getting the message there. So these are the salaries, guys. We are just extracting the minimum and the maximum, and then we are replacing the backslash n. Every company had a backslash n, which is like a new line character. So we're removing that one. That's what this does. Then describe is basic statistics. We're seeing what is the minimum values, maximum values. We try to spend some time and try to make some sense out of it ideally, guys. Okay. Then here is a little bit of visualization. Rating. Is that normally distributed? Now, what is normal distribution? That's a little bit of statistical understanding. If it is normally distributed, it is predictable. Is it left skewed? Is it right skewed? These are the concepts. Again, we'll go in detail. So a little bit of visualizations. So if something is a bell shape, then it is predictable, is what is the meaning of that. Then here is the box plot. It gives you minimum, I'm sorry, the quartiles, the average. The green line is the average. The average is close to, I think these guys are close to 25 years. Then average salary is close to $100,000. For data scientists, that is average. This one is very, very small because its scale is different. Ratings. The average ratings, it looks like, are close to 4. That's probably 3.6 or 3.7. These are all outliers. Okay, this is the thinking of a data scientist, guys. This is machine data scientist language. Okay, those are the things, again, we'll pick up. And again, we're only looking at these specific columns. We're correlating. How is the age? Is the age and the average. Okay, age and average, 0.01. That's a less correlation. Rating, less correlation, less correlation. Length of a description and the age. Again, correlation is a slightly deep one. And so it looks like there's some negative correlation. Rating and description of the job have negative correlation. Means if the description of the job is very high, If a company is giving a very long description, it looks like the rating is very less. So companies which are giving short and sweet descriptions, they are being given high ratings. The people who are working in those companies are giving high ratings. What is that? That is called a correlation. Understanding something like that is called an insight. Now what is that? That is something which we don't know and we are finding. That is what correlation tells, guys. Okay. Does it really mean it is very good? Well, we can still prove it. That is the starting point. Here comes a correlation matrix. So wherever it is dark red, it is more highly correlated. So if you look at age and description, that's slightly dark red. The lighter, the green. Rating is negatively correlated with description. We just discussed about that. Less rest of them are all positively correlated. Again, correlation is another common thing that we generally look for because that will tell us different kind of insights, guys. Okay. Now here is where we're taking the location, headquarters, size. In other words, we have totally maybe 20 or 30 columns by now. We're taking only a few of them, separating few of them. Okay, these are all, some of them are textual data. Now what we are doing is we're visualizing. Every column we are visualizing. So scroll down here. So here is the location. Based on location, there are too many of them, so it is not really, it's slightly messed up there. But in a particular location, there are a lot of jobs. That is probably New York, close to 50. Next one is maybe California, because those are the two top leaders. Then headquarters, similar to location. Then come to graph size. Take a look at this. This is much more meaningful. There are close to 1,001 to 5,000 employees. And what is this? The blue. There are close to 140 companies which have 1,000 to 5,000 employees. See, in India, we don't really worry that much. But in USA, some people will say, hey, I will not join any of these companies which are 1 to 50 because those are new companies. I don't want to join new companies. I want to join a company where there are at least 1,000. Some people think like that. So what is it? That's what this is telling. It's giving you an idea how many employees are there in each company. Cool. So that is about the company. Then let's scroll up here. Let's see what is this one. This is company private. Majority of the companies, close to 400 companies, are private companies. Some people may prefer, I will only join private, I will only join public. I will not join, maybe schools, maybe colleges. There is, things like that. That might be a preference of some people. That's also we can understand. Then comes the industry. Some are only interested in aerospace. Some are only interested in maybe defense or transportation. Looks like biotech. Notice biotech, most of the data scientist jobs are coming from biotech firms, guys. Are you all catching the point, guys? Can you give me a quick yes? Gentlemen, ladies, cool. So let's scroll down a little bit. Take a look at this one. Here is sector. IT sector has a lot of jobs. Most of the data scientist jobs are coming from IT, followed by pharmaceuticals, followed by business service. See that, guys? It makes sense. And the least one, agriculture, doesn't seem to have picked up. Accounting, no, not much. Go from right, it gives you different. Even telecommunications is surprisingly less here. It looks like for some reason pharmacy. Why pharmacy? Naturally, the COVID. Everybody is after COVID. That's why probably the biotech and pharmacy are coming up a lot. Actually, if you separate the IT, biotech is the most popular one today, according to this graph. Why? Because of the COVID probably, guys, okay? Because they're putting lots of money trying to analyze the data. And then revenue. Some people may have preference, I will not join two big companies, I'll join only small companies, 1 to 5 million. There is more opportunity, more innovative things happening there in small companies. That might be the preference. Then come for company text. Okay, this is not really meaningful. And in which state? Looks like lots of jobs are in California. Okay, it's very minimal. The result depends on the data set we have used. True. You have a point there. Good point, Shay. And looks like, notice again, Python. Python, what is orange? Orange is 1. Close to 400 jobs in Python, or close to, I'm sorry, same state. Same state is here. That means the same state means the headquarter and the same state are same. Then Python jobs, this is close to 400 jobs have Python 1, and the orange, blue one is how many jobs don't have Python. That's more than 50%. Again, visually, we just discussed R, very less jobs have R. Again, Spark is decent, okay, close to 150. SAS, AWS is also 150. So somebody was asking which one to take. So notice that, guys, Python, data scientist, and Python is one of the best even compared to AWS. It's here. It is close to only, again, close to maybe 150, 170, like that. Catching it, guys. And you analyze. For the sake of simplicity, I just took 6 or 7, but you create as many as you want. You give. What is it? That is data science. That's what they are expecting you to do in real world, guys. This is the kind of analysis they are expecting you to do. Cool. And the last one is job simplicity. Notice job simple, data scientist close to that many. For is AWS, it is not a must. Cloud is okay. It is not a must, Rashri. It's good to have, but it's not a must, mandatory thing. Cool. Any means these jobs are not available. Or in other words, for some reason, some of these are coming as NA means whether they are data scientists or what, it is not available. So there is more chance for cleaning. Cool. Then seniority. Looks like a lot of jobs are NA. NA means, again, as I said, freshers or maybe mid-level. That is the story of the categorical. These are all categorical columns, means textual data. Now here comes the numerical. Again, one more time, bar plot. What is this one? Okay, New York. No, these are also categorical. Location, headquarters, same things. Oh, here are the company names. Sorry. Oh, so more precisely, because there were too many results coming up, what we're doing is we're just taking the top 20. Because they were a little too messed up, we're taking only the top 20 results of location, top 20 results of headquarters, top 20 results of company names. Mass Mutual seems to be hiring, followed by Reynolds American, Takeda, pharmaceuticals seem to be the 3 highest ones. Cool, guys? And there's a pivot table. It'll tell you what is their average salary as an analyst. Let's take data, and data scientist is at $170,000. That's in US. We need to do the same thing in India. We need to do the same thing for each country. That's what companies are doing, guys. That's what companies want from you. Z-axis in graph may be there to analyze. Good one. That's 3-dimensional. Okay, you have a point. So that's the average salaries, guys. Then comes the, for analyst, if you're a junior, what is the average? If you're a senior, what is the average? NA means that's missing data. We need to take care. We need to fix that. We need to talk to business to fix that. Data scientist, junior, 106,000. Senior is 138,000. Unavailable is 107. That is close to junior. So probably those are all juniors and freshers, guys. Okay. So like that is pivot table. Then comes the job state. In Wisconsin, for data scientists, they're paying 113. That is in Washington, probably $99,000. That's close to 100,000. Cool. And then what do we have? Oops, sorry. This is job state. How many jobs are there? In Wisconsin, 3 jobs. In Washington, 17. Lots of jobs in Washington for some reason. There are some. Virginia, 18. So Washington, Virginia, I think maybe they are side by side. Okay. So that's what we are understanding. Then each state, what is the average salary? California. So think of that as maybe Andhra Pradesh, that is Telangana, that is this one. We just need to do a search on a different state, a different country, and we have similar kind of data. Then the rating based on the industry and the sector. Okay, based on ratings, what is their average salary? In the companies where the rating is 5, the average salary is, notice, 134. That means where the people who have given high ratings, they have given the salary is also high. With the rating is low, notice these companies have low, but still $120,000 they're paying. So different things are there, and based on the industry. In retail domain, they're paying 163,000. Obviously, that's a lot of, there's a chance for analytics there. Motion pictures means movies. That's also pretty good. Cool, guys. And scroll down. What else we have? Accounting and so on, and then scroll down a little bit. Sector, based on sector. That is what we have. Revenue. In the companies where they are making a revenue of 5 to 10 million, that's pretty good. 120. In Illinois, how much is it? Salary negative, is it? I didn't notice that wrong. If it is negative, something is wrong. That is bad data. We need to fix it. You need to come up with ideas. If you cannot come up with ideas, talk to business. Talk to your business users. Talk to your team. As simple as that. That's what we'll do as data scientists. Catching it, guys. And let's see, that is based on the revenue, based on number of competitors. If a company has two competitors, their average salary is 106,000. Now that is up to us, hourly. If something is hourly, they're paying $25, maybe. If they are not hourly, that's coming to be $103,000. Okay, so employer provided Python. In companies where they are asking for Python, they're paying $112,000 per year for data scientists. In companies which are not asking for Python, notice that is 87,000. Notice that, guys, this is real-time data. Gentlemen, ladies, that's a lot of useful insights. And if you compare Spark, Spark is, $1 higher than Python. So if you know Python and Spark, it's a double advantage. SPS is only 100, AWS 112, not bad. And now comes the type of ownership. Cool, guys. So I think there's some data issue there. That's why that error is coming up. So this is data visualization. This is the exploratory data analysis, guys. You're trying to understand how many of them. Again, Python and 1 to 2 billion. So this is called a pivot table. So we're looking at all the Python jobs based on the revenue. Like that, we can look at Python based on the company, based on the sector, based on the other things, and get a feel of them. That is what is called analysis. What are you doing? You're writing one line of code. Every one line of code is like a big program. If you're a Java or .NET programmer, you'll provide one page of code for that. You'll create a separate UI page and you'll show them. What are you doing? One line of code. That is what is the difference between Java's, .NETs, and Python. And now you take all the descriptions. Here's a word cloud. Looks like the bigger the size of this words, the job descriptions are looking. So notice support work, data, learning, data science, solution, team. Team means maybe they're looking for team players. They're building a solution, a data science solution. And their learning is also, it is saying, hey, you must be interested in learning new technologies and things like that, right? So these are the words which are appearing a lot. If the size of the word is less, that means it is less. Cool. Azure or AWS is different from this one. Yeah, both of them are different, Preeti. AWS Azure is Azure ML. Azure is Microsoft's competitor. I'm sorry, AWS competitor for cloud. Azure ML is what we'll be learning. We'll be learning how to create machine learning models on the cloud. We don't need to go into the other concepts. You can create a very, very useful report based on this, Ram. And who? That is for yourself. Now just imagine for companies how much we can create. What I'm showing you in maybe 15, 20 or in half an hour, we will sit on this for 1 week, 2 weeks or 1 month and we'll create a report. To give you an idea, I'm showing you real quick, guys. I hope everybody understand. So let's save it to EDA data. Gentlemen, ladies, time to build a model. Okay, just giving a rough idea. These are all the columns we are taking. We convert, this will convert everything to numerical. Because I'm almost summing it up. I need to close this, guys. Sorry about that. So average salary is what we are going to be predicting based on the rest of the things. Based on all these things, we are going to predict average. That is what we are doing here. So here we are building a linear regression and it gives us an output like this. This is stats models output. 70%, that is called the variance we are able to explain. And if you scroll down, it's telling you your average salary. These coefficients are interpretable, guys. Okay, so let me take Python. Your average salary for every 1 unit of Python. Okay, that's slightly difficult to interpret, but it is interpretable. It is roughly saying how much salary is increasing for every 1 unit of Python is what is the meaning of that, guys. Hive is there, buddy, but I'll be going more into Spark, Rajeshri. Sorry. I will be skipping a little bit of Hive because all the Hive is nothing but Spark SQL today. I'll be focusing more on Spark SQL, Rajeshri. These things will also tell us a story. That is, again, due to lack of time, I will not spend much time. And now negative mean score. So this is, the lesser this one, the better it is. We are getting a slightly negative thing. So it should be close to 0. is what is the meaning of. Then we will use different models. Here is random forest regressor, less negative score. Then grid search, this is called hyperparameter tuning. I cannot explain all these things now. So like that, we'll build 5 to 10 models. We'll see whichever is giving the least error. That is the model we will use in real world. This is what we do in the world of data science, guys. Okay. This is one of the last projects that I will be explaining, but to give you an idea. Requirements for Python, again, Ram, you don't need to be a programmer or anything. I'll be starting from basics, buddy, from tomorrow, if that is what you're asking. Okay, guys, gentlemen, ladies, it looks like I'm almost out of time. I'll give you about 5 to 10 minutes, guys. Any questions? Can you just quickly type in? The first 3 months will be during weekdays. The last 1 month will be during weekends, Rishi. Yeah, Pankaj, I'll have the support team share the syllabus, buddy. Sorry about that. Give me one moment, guys. I'm going to put you on hold for one quick second. Sham or Balaji, can you share the contact number, please? Okay, great. Thank you, Rajesh. I appreciate that, buddy. Why value of their... I need to look at Rajeshri. I don't have an answer right now, but I'll need to dig into it a little bit. Sorry about that. Is there function which are inbuilt? We need to write. Functions are all built in. You need to know when to write them. First thing round. Second thing, we will also need to learn to write the functions round. Don't worry about that. That's what I'll help you in catching up with. Catching it, buddy. Cool. I will start with the Python first, then move on to R. Yeah, I think they're all pretty reasonable. Cost is also pretty reasonable. That information these guys will share. The support will share. Yes, you can also apply stats models. Jupyter. Yes, Jupyter and Spider. If time permits, I'll also show you Visual Studio Code. Any one, if you know, others will become easy, guys. Very good. Others, yeah. Yeah. So, yeah, you can rejoin, buddy. Just let them know. 8 to 9, guys. 8 to 9. Maybe I'll go till 9:15. Just work with me. Life sciences, huh? Yeah, Naresh. Sunny. Is life students. Life science students? Yeah. If you're asking life science, yes, but I'll cover Spark in a little bit more detail, Sanjay, more than Hadoop. Hadoop, I'll give you an introduction, but Spark I'll cover in a little bit more detail. Mechanical engineering, yes, definitely you can. A lot of guys who are coming from mechanical engineering, in many other engineerings are also learning Praful. And again, don't worry, I'll be starting from the basics of Python. Biotech, yes, Naresh. Okay, guys, data science, that is why it is called the sexiest job of the 21st century. You don't have to have a very hard background. Deep learning is one of the most important things, Sanjay. Machine learning and deep learning are your most important things I'm covering. Without that, it is not data science. Cool. Okay, so gentlemen, ladies, for today, allow me to sign off here. I hope it was helpful and I hope it has given you an idea. And I will go ahead and sign off. I need to get on to another call and things like that, guys. You guys take care. I look forward to meeting you guys. And whether here or somewhere, definitely learn it, guys. It's a course which is worth. It will be very, very helpful for you if you're in job search and things like that. You want to talk to me in personal. As assistant, is it possible to have in IT industry? Yeah, absolutely, Praful. Is it possible to enter? Yes, absolutely, Praful. Short answer is yes. And Preeti, I'll share my number here in case I will be in a call for a few after this one. Okay, this is my number. I will be called for the next half an hour to 1 hour. Just send me a message and then I'll talk to you. Okay. Django, no, Ram, this is not Django, buddy. Django is only the UI. I think they will put this also on the YouTube, guys. Pratham. Okay, Praful, short answer is yes, buddy. Sorry, I'm not able to spend too much time. Okay. Guys, was that, I hope that was helpful and useful. If time permits, please join and we'll continue the journey from tomorrow, guys. With that, I will sign off here. I wish you all guys good luck and give it a good attention, guys. It will be helpful and useful to you. So bless you all. Thank you for joining and signing off for today, guys. Thank you and bye for now. I will have the support team here. They will share the information you might need, guys. Thank you, Manish. I appreciate that, buddy. Hopefully that was helpful for everybody. Thank you all. Signing off. Bye for now. Thank you again.